Thank you, everyone. And I'll acknowledge that this is September 22nd. We're still in the middle of COVID. So I've taken my mask off, but everyone in the room is masked and socially distanced. So I'm happy you could all join us here today. Just for orientation, this is a 3-hour seminar in 2 parts. The first part has to do with the pedigrees and the gene pool of your breed and about breeding. And the second part is about health and genetic testing. And there will be, so that the first part is going to be about an hour 15, hour 20 or so, and we'll take a 10-minute break, and then we'll conclude, and we will finish by 7:30. So the title of the seminar is The Genetic Health of the Bearded Collie, and that sounds very daunting in terms of, is this going to be really scientific? But it's really not. It's really about the practical genetics for bearded collie breeders and owners. And so if you have no genetics background, that's okay. Any of the terms that I'm going to use, I will explain, and there are very few of them that are involved. I also want to thank everyone that is viewing the seminar, and this is being videotaped, so it'll be available to the rest of the club members who donated pictures of their dogs off the internet, or that I stole off the internet to make the presentation more directed towards your breed. So if you see your dogs up there, you can silently applaud them. All right, as background, I am a member of the board of directors of the OFA. It's a volunteer position. It's a not-for-profit animal health foundation dedicated to the genetic improvement of dogs and is the largest database of health testing information in the world for dogs. I am a small animal practitioner in my day job at Freshwater Veterinary Hospital in Connecticut, where I take care of primarily pet dogs and cats. I have a breeder veterinarian that is a few miles from me that has all of the breeder clients. And so primarily I'm seeing pet dogs and cats, which is what you are producing. And so I get to see what is being produced by breeders of all breeds, as well as mixed breeds. And it gives me insight into what we are dealing with in terms of dogs and cats with genetic disease. I am myself and my wife, so I claim to be a breeder, although my wife makes all the breeding decisions. I get to pick up poop and things like that. This is our boy Bobby, who's at home right now. This was the day he attained his junior hunter title. And this is his litter sister, Maddie, when she took breed at Westminster a few years ago, when it was 3 years after her mother took breed at Westminster, and these were both homebred dogs. We breed very few litters, but we really pay attention to what we're breeding and what we're producing, and that they can do what the breed was intended to. And that's very important for working breeds or breeds that were bred to do something. We often have problems with breeds that have turned into companion breeds that are no longer being utilized for what they were selected for 20, 40 generations. And we run into problems with those. We run into OCD with a lot of breeds that were very active, and they're trying to adjust to being just a house pet, and that's not what they were bred to do. So it's really important that even if you're not hurting your dogs, you at least maintain the attitude that is behind them, and that you at least give them the opportunity to do some herding work so that you can see that you are propagating what was selected for, because otherwise breeds can go in different directions that are not necessarily the healthiest for the dogs. Okay, we're going to do polling today, so I need you to pull out your phones, and the easiest thing to do is go to a website, pollev.com/BCCA. And so this is just a test poll to get you oriented. Or if you want to text, you're going to text to the address 22333. That's the address. You're going to type in BCCA and hit send. And then from then on, all you're going to need is to hit the letters for your response and hit send. If you go to the website, which is the best place to go, and it'll ask you if you want cookies, and you can dismiss it. You don't even have to ask, let it give cookies. It's totally anonymous what your answers are going to be. The questions will all pop up automatically, and you can just put in your answers. So that's the website, pollev.com/BCCA. or you're texting to 22333. You're putting in BCCA once only and sending, and then after that, you're just going to type in A or B and send. All right, so 100% of you love bearded collies, and no one in the group loves Siamese cats, so we are in the right place. Okay, so the next question, what is the greatest genetic health issue of bearded collies? So again, this is completely anonymous. This is a free form. So if you're on the website, there's a little box there. Just type your answer into the box and send it. Or if you're texting, you don't have to do BCCA again. You're already oriented. Just type in your answer, what is the greatest health concern, and hit send. And your answers will automatically show up on the screen. There is no moderating, so let's please hold the profanity. Yeah, I really hate Siamese cats. You don't need to do that. Greatest genetic health issue of bearded collies. Addison's disease, autoimmune disorders, not enough gene diversification, autoimmune. So we will be addressing all of these things so far, autoimmune. So anything aside from autoimmune if it's already been up there, or be more specific. Lack of broad gene pool, inability to use molecular genetics to screen against autoimmune diseases. Absolutely, we have a lot of research, but not yet really for commercial use that we can actually use to screen. Hemangiosarcoma as a malignant cancer. Okay, all right, so we're going to address all of that today. And the last thing, what are your questions concerning the genetic health of bearded collies? So what would you like to find out tonight? Better understanding of coefficient of inbreeding, we'll definitely do that. How to improve the health of our breed, that's what it's all about. I know you already stated about having practical ways to select against autoimmune disease, and we'll talk about ways to select against any diseases that don't have genetic tests yet. And then as we develop genetic tests, understanding how they can be used and using them properly. How to increase gene pool with healthy progeny. Absolutely. Genetic markers for specific issues or concerns, and inheritability of certain conditions. Are they inherited, or how are they inherited if we know that? How many perceived genetic problems are too many to justify removing an individual from breeding consideration? We'll talk about that in the first half as well. Okay, moving on. So a large number of individuals in a breed population provides greater choices when making breeding decisions. So you want to have a large enough population to choose from to be able to select for what you want and move away from things that you don't want. So that is certainly an important aspect of any breeding. And selection is the most important thing that we deal with as breeders. It's who you select for breeding and who you breed them to. But specifically, who you select for breeding is the biggest and most important decision that you make. And you need to make that one first. Who am I using for breeding? If I'm a bitch owner, or if I have a male, and specifically I'm looking to replace and develop more breeding stock for my program. And then who do I breed to as well in that regard? So that's what changes breeds. It's what's created all the different breeds. And selection is a very powerful tool. I mean, we have created from the ancestral dog over 400 breeds of dogs around the world that are vastly different from each other in looks, in what they do, in conformation and abilities. And so it's a powerful tool that responds to what we do. But if we're not selecting, then we're going to have problems because then everything can go anywhere. So it's really important about selection. And then with each selected trait or disorder, the proportion of the available gene pool decreases. So we also need to understand that as we're putting selection indices in, I have this genetic test, I only want those that are normal. I have this characteristic, I only want dogs that have that characteristic, that we're eliminating portions of the gene pool that don't have those things. And so we need to make sure that with each selection indice that we're using, that it's a proper selection, that it's actually selecting for what we think it's selecting for. Otherwise, we're wasting selection, we're diminishing our ability to progress with the other things that we want to select for, because we're limiting our other choices, and we may bypass certain dogs that are actually the perfect dog for us if we're using improper selection. So if we say that this is the gene pool of the Bearded Collie and all the dogs reside within the circle, and then we have a genetic test or something that we're selecting for, and only this proportion of the breed has that trait or genetic test result, and so now this portion of the breed we're no longer considering for breeding. And then we add another layer of selection to it, and now it's only the overlapping segments that we're looking at in that area to select dogs to breed and to breed to. And we add another layer of selection, a trait or a characteristic or a genetic test, and then we add another one. And so very rapidly what happens is there's only a very small portion of the gene pool that we're actually looking for dogs that qualify at all of those levels of selection. And that's why selection is so important, that's proper selection, and that we're not eliminating individuals that really fulfill what we want, but we're eliminating them improperly, and therefore limiting our ability to improve the breed and what we are breeding. So let's talk a little bit about the registration statistics of the Bearded Collie, and we're not going all the way back this far. So I'm going to go back to 1985 and go by 5-year intervals up to 2010, and then by single-year intervals from there. And these are the AKC registration statistics, the AKC rank, and the number of individual dogs registered. So in 1985, the Bearded Collie ranked 72 and had 887 dogs registered that year. In 1990, you dropped to 79. There were 700 dogs. 1995 ranked 87, 762 dogs. And it actually went up, but the AKC is adding a whole bunch of more breeds that have more registrations than your breed, so you're getting pushed down in the rankings. So dropping in the rankings isn't necessarily linear in terms of you're comparing 72 to the 120s here, because they've added 40 or 45 breeds throughout that period. But we do see a decrease, especially after 1920s with the first economic collapse of our lifetimes, or at least our generation. And so the numbers dropped down there and then muddled around in the high 200s for a while and then continued to drop. And now they're just starting to come back again in the last couple of years. And this is what we've seen with every single breed. So it's not just your breed that's happened to. This is all due to economic circumstances. But the numbers of dogs have significantly gone down, and they've significantly gone down to a quarter of what was around in 1985. But again, every single breed has that. So that's why it's important to understand that this is what we're dealing with. If we look at number of litters registered, from 189 litters being registered in 85, and then we're dropping down in the last 5 years or so into the high 40s for number of litters being produced. And so that's what you are producing as a breed, not just club members, although Bearded Collies is a smaller breed, so you have a greater percentage of dogs being produced by club members than for Golden Retrievers or very, very popular breeds. So you have better control as a club over those things, but also other people that are breeding Bearded Collies as well. And Dr. Sell, I have to say, and she's not here, right? Because she said she wasn't traveling. I don't know how much she by herself does the Beacon Health database and registry, but she has done a phenomenal job. So you guys are so lucky to have her to be able to actually give you valid data, because valid data is important. Because data that's not really that valid, who cares? It's not telling you the right stuff. And she has done a phenomenal job giving you information. If we just take the AKC information and divide the number of registered dogs by the number of litters, and we know that that is not going to be an absolute number of puppies per litter because lots of dogs are not registered from litters, so it actually should be a little higher number than that. But if you just take that ratio, in 1985 there are 4.7 dogs registered per litter. 4.1, 4.0 into the threes, 4.1, the threes again, fours, 4.5, 4.2, 3.9, and in 2020, the last full year registration, 4.4. So there doesn't look like there's a whole bunch difference in terms of number of puppies per litter. Since 1985, you're registering just about the same number. So there's not a significant decrease. And if people say, well, we've got smaller and smaller litters, it's not being reflected in the AKC registrations. Now, in the Beacon registry, they have collected data showing the percentage of litters with less than 4 pups. And again, if we're dealing with an average that's 4 to 4.5, somewhere in there, the percentage that's less than 4 is going to be almost half or a large amount that you would expect in that regard. So that cutoff point actually skews our data a little bit. But here we have, and I'm not sure how that data was collected, because how do we know how many pups were born in a litter versus the registrations? I'm not really sure how that was done. But it's showing here a trend of smaller litters where before 1980, less than 10% of litters had less than 4 pups. And now we're up to almost 27% of the litters with less than 4 pups based on that data. Now, again, that is not reflected in the AKC registrations, but we have to feel that this data is reporting something. What we also need to understand is that every single breed has seen a drop in litter size over this period of time. And it's not just genetics that does that. There are a lot of environmental triggers. There are a lot of hormone inhibitors. There's lots of toxins in our homes, in our carpet and furnitures, in terms of fire retardants. We have lots of new diseases that we have traced back to environmental toxins, and lots of other things that we don't know yet. So what we're doing, and in people, reproduction has decreased accordingly, just as it is in dogs. So we can't blame decreased litter sizes just on inbreeding or bad genes and genetics. We need to understand that as well, that if there is a decrease there, or if we are having issues, that there's a lot more than just genetics involved. But based on Beacon data, there is a trend there for smaller litter size. A more important aspect that we need to look at is the number of bearded collies that are bred versus how many are produced, because that's really where the issue about breeding comes about, and the differences between species and breeds. In species, everybody reproduces or gets an opportunity to reproduce, whereas in breeds, the only ones that reproduce are the ones that we select for breeding, and the rest of them do not reproduce and pass on their genes to the gene pool. And so when we look at the average complement, or the percentage of dogs from litters that have been bred, you need to go back, because some dogs aren't bred till they're 4 or 5 years of age. So if we go back to this area here, what we see is about somewhere less than 10% of all bearded collies are ever bred. So that's a genetic bottleneck. And so we need to understand that every generation of breeding is a genetic bottleneck, that we're only selecting 10% of the breed to reproduce and represent the breed and pass on genes for the future. So that's why it becomes even more important that who we select for breeding is the right dogs, are the best dogs that we can use. And the worst thing you can do is say, oh my God, this decision is so important, I can't make it, I'm not going to breed. Because the worst thing we can do is not breed, because then you're going to lose your breed. You're afraid of losing it and losing your gene pools and losing diversity. So you have to breed, but you need to make your best choices you can, and then see what you produce in that way. So I've taken the AKC information from 2010 to 2016, so that gives us 4 and 5 year olds that we're looking at, and what is the average percentage of dogs bred versus those registered by the AKC. And you need to break the breeds down to, and I've broken them down into thirds: the most populous third, the middle third, and the bottom third. All right? Because it's very different. Because populous breeds, you have much, much less of the breed reproducing because you've got a lot of pet dogs. And the smallest breeds, you've got a lot more being bred by club members and being utilized by club members, and therefore there's a higher percentage. So the bearded collies actually show up here for the middle 1/3 of AKC breeds. You're right at the edge of the middle third, just above the bottom third of breeds. So that's about where you stand in terms of your population rank amongst other breeds. And so you're right here, and the average is 11.3% for this middle group, and for bearded collies it's 8.9. So you're using 8.9 of your registered dogs for breeding for the next generation. And that is a bottleneck, so that makes your selection that much more important. So the next part of the talk is mirrors an article that's all over the internet for the past 20 plus years. The ins and outs of pedigree analysis, genetic diversity, and genetic disease control. There's a synopsis of that article in your handout. The full article, if you Google ins and outs of pedigree, you'll find it in many places. There's one copy on Serious Dog. But I've modified it to be specific for your breed. So, but before we go into that, there's a poll now. And the next question is, my last mating was an, or if you have never produced a litter yet, what you think you would prefer to do. It's an inbreeding, a line breeding, an outbreeding, an outcrossing, or a crossbreeding. And of course, you're sitting there saying, well, can you define those for me? And I will on the next slide, but not until you answer the question is about what you think that you're doing with your matings. So my last mating was, or I prefer to do, inbreeding, line breeding, outbreeding, outcrossing, or crossbreeding. Okay. So 50% of you say that you're doing outcrossing, and 30% say you're line breeding, 20% say you're outbreeding. So actually, outbreeding and outcrossing, you're all thinking you're doing the same thing. So 70% of you say that you outbreed, and 30% say that you line breed. And nobody's crossbreeding because that's designer dogs. You know, we used to say no one crossbreeds, but now a lot of people crossbreed, okay? All right, so let's define these. Inbreeding is breeding closely related dogs. And as breeders, I know that an inbreeding to you is going to be a father-daughter, full brother, full sister, that those are inbreedings, and it's not something that people do very often. Line breeding is defined as a less intense form of inbreeding. It's concentrating the genes of a particular ancestor. Outbreeding is breeding dogs less related than the average of the population. So the difference between line breeding and outbreeding really depends on what the average inbreeding coefficient, or COI, of the population is. And are you doing a mating that's above the average, which would be a line breeding? It's a more tighter breeding than the average. Or are you doing a mating whose COI is below the average of the breed? Are you doing an outbreeding or breeding two dogs that are less related than the average in the population? Outcrossing is what breeders tend to call outbreeding. So that's the word that has gotten fixed in the lexicon of breeders. But we, as geneticists, we like to save the word cross for crossbreeding. If you're doing a cross, it's between two different breeds or individuals from different breed backgrounds. But outbreeding, outcrossing are the same in your minds, and that's less related than the population. As a geneticist, any mating between purebred bearded collies has inbreeding involved because there are common ancestors between the sire and the dam side of the litter. And we can calculate that with an inbreeding coefficient, or COI. Okay, so there are So this slide is one I have to eventually update, but I look at 3 different populations of dogs, and there are now 4 different populations of dogs. But purebred dogs are dogs that are matings between 2 bearded collies. Designer bred dogs are purposely bred, crossbred individuals from 2 different breeds. Random bred dogs are dogs who reproduce on their own, either feral or village dogs, and no human makes that decision as to who is bred. And so I used to say that this really represents 2 different populations. In purebred and designer bred matings, a human is deciding what dog breeds to another dog. So there are responsibilities that we have as people in terms of who we select for mating. And random bred dogs, the dogs make that decision themselves. We really can't control that. In reality now, with the bred for rescue that's been going on, because everybody wants a rescue dog now. You know, for a while everyone wanted designer dogs because supposedly they're more genetically healthy. Well, now we know that designer breeds that have been around for over 20 years are not more genetically healthy, but that was the public conception. And now the public conception is, I want to rescue dogs. So I want to adopt a rescue dog and feel good about rescuing a dog. And there's certainly not enough stray dogs out in America and out in the world in order to produce the dogs that America requires. And so now you have breeders that are breeding mixed breed dogs for rescue. You know, it's amazing, all of these rescues that come in and they're all, 7 to 10 week old puppies. You know, it's amazing how many stray puppies there are out there in the world. But that is a purposefully bred dog. And so the bottom line is purposefully bred, whether it's a breeding within a breed or an outbreeding or outcrossing or a crossbreeding. If we're breeding dogs, we need to ensure that we're breeding healthy dogs and that we're going to produce healthy dogs. So here's one of my favorite comics, and Rob says, ever heard the expression familiarity breeds contempt? And Satchel sits and ponders, and he says, no, in the dog world we say familiarity breeds hip dysplasia. So this is the view of America, of the public, that purebred dogs are inbred and it causes disease. Okay, and this is the view of a lot of breeders as well, is that inbreeding causes disease. And we need to get beyond this and understand what's actually going on when we do mating. So let's talk about that. So here's the scientific part. There are 2 things I need you to understand. One is the inbreeding coefficient, or COI, also known as the Wright's inbreeding coefficient, or because Sewell Wright is the one that came up with the formula. And I'm going to read it first and then we'll define it. The proportion of all variable gene pairs that are likely to be homozygous due to inheritance from ancestors common to the sire and dam. So what does that mean? So the proportion of all variable gene pairs. It's the genes that vary. So gene pairs, each gene has 1 copy that you get from the sire and 1 copy from the dam, and they are paired up. And the variable gene pairs are only the pairs that have variation within your breed of bearded collie. So the gene pairs that make a dog are non-variable. You always get a dog. You don't get a chicken. Like, oh my God, I got chickens this time. All right, and breed-specific genes. When you breed a bearded collie, you get a bearded collie. A little chihuahua doesn't pop out every now and then, right? So those are non-variable gene pairs. So we're only talking about the genes that vary within your breed, that are likely to be homozygous, homo meaning the same. So we're saying that the gene that's coming from the sire side of the pedigree and the gene from the dam side, if it's a big A, it's going to be a big A. If it's going to be a little a, it's a little a. Those are homozygous. Doesn't matter whether it's a big A or a little a, it only matters that they're paired up together. The opposite is heterozygous, hetero being different. So a big A paired with a little a. All right, so proportion of all variable gene pairs homozygous due to inheritance from ancestors common to the sire and dam. So if you have an ancestor that's on the sire side of the pedigree, and you have another ancestor on the dam side of the pedigree, what's the chance of the genes from that ancestor coming down both sides of the pedigree and pairing up and being homozygous? So that is what that inbreeding coefficient tells you. So if it's 17%, then there's a 17% chance of getting homozygosity at a variable gene pair due to inheritance from all of the common ancestors between the sire and the dam side of the pedigree. So that's all of the gene pairs. 17% of them will be homozygous. Another way of looking at the COI is only looking at a single gene pair and saying, what's the chance of that single gene pair being homozygous? 17%. Okay. The other number I need you to understand is the relationship coefficient. So this is a measurement of the probable genetic likeness between the individual and a particular ancestor. It is the probable percentage of genes the individual in the pedigree who you're looking at and the ancestor have in common from descent. So if you say line bred 17% on so-and-so, we expect individual X to have 17% of their genes coming from that ancestor. All right? And there's a complicated formula for coefficient, for relationship coefficient, but it is easy to compute it as a percent blood calculation. And that's going to be pretty much almost exact as to what it is. The difference between those two is that the amount of the inbreeding coefficient of individual X and of the ancestor, if the ancestor's inbreeding coefficient is much higher, then you get a higher relationship coefficient slightly. And if the ancestor is more outbred than individual X, you actually get a lower percentage of their genes in that regard, but it's a very small amount. So percent blood is just taking the position in the pedigree and saying what percent comes from that individual. So a parent contributes 50%, a grandparent 25%, a great-grandparent 12.5%, and you cut it in half with each generation that you go back. So if you have a great-grandparent on one side at 12.5%, and they're a grandparent on the bottom side at 25%, then the percent blood or relationship to that ancestor is 37.5%. So, and then if they appear many, many times, then that percentage adds up. If they're way back in the pedigree, the amount that they contribute is extremely small. But if they're way back in the pedigree, because we're a pure breed, they can appear hundreds of thousands of times. And so their influence can actually be very strong, and we need to understand that. Okay, so this is the first slide that summarizes the Beacon registry. And again, I just have to do a shout out to Dr. Sell and whoever else has worked on this database, because it is the best. I've done now close to 75 Parent Breed Club seminars where I've analyzed a computerized pedigree database. And the analysis can only be as good as the database. If there are lots of dogs in the database that have unknown parents, then the computers think that that's a founder. They think it's new blood coming into the breed, when in actuality it traces back to everybody else. It's just that the dogs aren't in the database. And this database is great because there are very few. I think there's 26 dogs that don't have both parents in the database. And that's pretty amazing. So we've got great numbers here. So what I want you to see here, it's broken down by decade from the 1950s to this decade is only 1 year old, so 1 or 2 years old, so you only have 144 dogs in there now. And what you see is the population growth, rapid growth from the 60s to the 70s to the 80s, and then you see that decline that goes on the 90s, and then 2000s, and then 2010s, and then this decade now. This is the average number of generations in a pedigree for all of these dogs, from 7 generations in the 1950s, and the generations before just don't, the dogs without birth dates that are in there, because it's historical records and we don't have pedigrees and birth dates for everybody. So we're still going back 7 generations to the founders of your breed. And then as you see, today's dogs have over 31 generations on average in their pedigree. Let's jump to this column here, the mean number of unique ancestors in the pedigree. And so what this is if a dog appears once, it's a unique ancestor. If it appears again, you don't count it again. So how many bearded collies actually contribute the genes and to the pedigree? You're starting with 20 dogs in the 1950s, and you're now up to 653 dogs in our current generation. So here is the COI, or inbreeding coefficient. and look at the all-generation inbreeding coefficient. This is utilizing all dogs in that pedigree back to founders. You're using over 30 generations. And so we start at 15.3% because we're actually only going back 7 generations on average. And then we see it go up over time, and it peaks in the, and it goes up over time, and the all-generation inbreeding coefficient can never go down. Not unless you're crossbreeding or breeding in new blood to say, okay, this dog looks like a bearded collie, we're going to use it. We're now going to crossbreed. So in a closed gene pool, the total inbreeding coefficient or homozygosity can only go up, it cannot go down. That's not necessarily a bad thing, it's just the way it is. If we look at 10-generation inbreeding coefficients, that's what we normally look at. We base a lot of things on 10. We have 10 fingers, 10 toes, so that's what man has done. We go on 10s. And if you look at a 10-generation coefficient, it equals the all generation initially because you're not even going back 10. But you'll see it goes up, and it peaks in the 2000s and then starts to go down. And so what that tells us is that individuals in the pedigrees beyond the 10th generation are no longer being used to calculate that inbreeding coefficient. So your 11th and 12th and 13th generations are no longer being calculated. And so what it tells us, and on one hand you can say, well, then that's not a true representation of homozygosity, which is true. But what it does tell you is that as you're doing more and more breeding, you're utilizing the breadth of your population. And you're not focused and truncating on a single family line that has all that inbreeding within 10 generations. So you're using the broader scope of your gene pool for breeding. And so that's a good thing that number starts to go down over time. When you look at just 5 generations, so that's purposeful in line breeding. Okay, because between the 5th and 10th generation, you're not really looking at individuals in the 6th to 10th generation and say, I'm line breeding on those guys back there. You're looking within 5 generations as to who you're line breeding on. And so what we see here is that we're peaked up top here at 5 generations, but we keep on going down over the generations. So this reflects what you showed me in the poll, is that most of you think that you're doing outbreeding or outcrossing because within 5 generations, you're not doing a lot of line breeding. And so that is reflected here, and this tells us that, once again, you're using the breadth of your gene pools in making your mating selections, and that's a good thing. So that's what this tells us from the Beacon database. And so, again, over time, bearded collies, the all-generation coefficient can never go down. It only goes up. The 10 generation starts going down at 2000, and the all-generation has gone down across the entire history of your breed because you don't tend to do tight line breedings. If there was really strong popular sire and an individual kennel truncating on the breed, this 5 generation would go up with everyone else. It would not go down in that way. When we compare to 10 generation inbreeding coefficients, and I have to update this slide, so mainly this is the 1990s that this slide is based on, it looks like your breed, so if you're looking at the 1990s, 10 generations, you're at 26. It looks like for your breed, you're at the top of really tight gene pool breeds, such as the Norfolk Terrier or the Tollers or the Bull Terriers, Bichon Frise, which you think is a very populous breed, but there's huge popular sire effects where a popular sire gets replaced by their son who becomes a popular sire, gets replaced by his son who's a popular sire. But we really can't compare your numbers to these breeds because these are based on pedigree databases that are not as complete as the Beacon database. So we really can't compare them in that way. And in actuality, what number was it? The 27%, 26%, or we're down to 18, but it's only using a small amount. Let's say 23.9% there. That is really an average for most breeds. I mean, maybe just below the average in terms of homozygosity of your breed, but you have a fairly diverse breed. You're doing diverse breeding here, so you guys are in no way in needing of rescue protocols to save your breed because of genetic diversity. You've got a diverse gene pool that you are working with. So here's the EMBARK COI analysis. So I know a lot of you have sent DNA to EMBARK, and we'll talk about EMBARK a little bit more, especially in the second part when we talk about genetic testing. So when the molecular geneticists calculate homozygosity, they are actually calculating the true homozygosity of genes in your dog. So it is a much more accurate representation of homozygosity, the all-generation homozygosity. And so this tells us how great your pedigree database is, because the average homozygosity based on molecular genetic analysis from EMBARK is your mean and median is at 31%. And your all generation based on the Beacon pedigree database is 29 point something. So they're really the same. And that's how crazy it is that your pedigree database is so complete that it actually mirrors the molecular genetic homozygosity, because that doesn't happen when I show this to any other breed group. You know, you're 10 points away with others because of those truncated pedigrees in the database. So 30% is not that tight for a pure breed. So again, showing us we have a lot of diversity. 70% of the genes, of the variable genes in your breed are variable, that there are multiple numbers there and they aren't paired up and homozygous with each other. And so I also have the AKC registration database. So I have confidentiality agreements, and I'm one of the few people that the AKC will share that with, because they know I will protect their data. But the issue with the AKC database is that the purpose of their database is not to fill in all the pedigrees like the Beacon database. All it is a registration. And when they switched from their big mainframes down to their new systems in the 1980s, they did not import the early stud books. So they only imported and started collecting pedigrees in the early 1980s and added 3 to 5 generations on pedigrees that were being used for registration. And so really, there's only this many dogs that were born in the 1970s and then the 1980s, and you can see it's a much more truncated. It only goes back 20 generations rather than 31 generations from your database, but it shows the same thing. And also because there are new dogs being added, there are imported dogs that only have 3-generation pedigrees. It looks like your all generation goes down, which we know it can never go down. But what it does show us is that once again, you are utilizing the breadth of your pedigrees. You tend not to line breed within 5 generations. And even in 10 generations since 20,000, you have been diminishing your inbreeding in that way. So it shows us the same thing that the Beacon database is showing us. Okay, so now using the Beacon database, these are the influential ancestors in your pedigrees. And I did an analysis like this for you in 2017, and because it's the same population, even though we're now 4 years down the line from that analysis, the results are going to be the same, because you're not going to change your background. You can't change who you are. So it's the same results that we have. So the dogs in the 1950s, 24.3% of their genes came from Bailey of Bothkanar, who was born in 1948. So he was born in 48, and in the 1950s, he's already contributing a quarter of the genes to every single dog in the database on average. So he had a very quick and fast contribution to your breed, and luckily he was a healthy dog and had healthy genes. Otherwise, you would have a very sick breed in that way. And Ridgway Rob was his sire, born in, Bailey is the sire of Rob. So in 53, he jumps up to 17.8%. Newtown Blackie was Bailey's sire. That's what it is. And Blackie was one of the founders of your breed, 15%. Britt of Bothkanar, 13.4. Dandy, Jeannie of Bothkanar, Here's a lot of your founders without birthdays, and these are what contributed in the 1950s. In the 60s, Bailey's influence went up, Rob's influence went up, Blackie's went down, Brit and Dandy's went up, Jennifer's of Moultons went up. Some individuals lost their influence, so they were being, whether they were being selected against or their descendants were. And what's happening is if they're not producing quality and passing on quality, you're not going to be used. So those individuals lose their influence. And Kitty Norton, same thing there. You go to the 1970s, you lose some more. The Brass-Nosed Bonnie and Annabelle fall off down there. Bailey increases some more. Ridgway Rob increases some more. Dandy increases some more. Some of them go down a little bit. 1980s, Bailey and Ridgway Rob continue to go up. Dandy continues to go up as a founder. 1990s, again, going up, going up, going up, going down a little bit. Bobby of Bothkanar in 56, his numbers are going up. 2000s continue to go up on their influence. And what that tells us is that whatever the quality, you guys aren't selecting for Bailey of Bothkanar at this point. You're selecting for quality. And so what it's telling us is that Bailey's descendants for generations are passing on that quality where his influence keeps on increasing. Okay, so you're trying, with a third of your genes coming from Bailey, you're trying to reproduce the dog that was not a founder, but epitomized the quality and the best quality of your breed in terms of what you're selecting for. It might not have been all there in his phenotype, but in his genotype and what he has produced over the generations has caused you to continue to select for him, because there are plenty of other dogs from the 40s that were around whose genes did not get passed on. And even if they did into the 50s and 60s, if they were passing on bad things, they still were being selected against, and their influence would diminish. And every decade, these dogs' influences are going up. And then lastly, the 2010s lastly, the 2010s, we see those numbers continue. Actually, a drop by 0.2 here, not a significant change. But these are the most influential dogs in your pedigree. So if you think I'm line breeding on someone and that's the most influential dog in my pedigree, you're wrong. Okay, the most influential dog is usually going to be Bailey in that regard. Okay, so let's look at a couple of pedigrees of dogs. And I selected these pedigrees based on the way the pedigree lines up and how they were bred, so that I can show you examples of different things. So not necessarily the dogs that are behind everybody, and if I chose one of your dogs, good for you, but it's really just to be used as an example. So the first pedigree is a dog called Tolkien Raintree Mr. Baggins. He was born in 2004. It's a male. Anyone know about this dog? What was his call name? Roy? Okay. And Roy had 22 offspring in the database. And what we see, so in a pedigree, if you're not used to looking at them, a sire's on the top, dam's on the bottom, the sire's sire is above the sire's dam, and so forth throughout each generation. And what I do when I look at a pedigree is I take out my colored markers. Well, I used to do this, now we do it on the computer, but you take out your colored markers, or actually the program does it for me now, so I don't even have to take out colored markers. And any individual that appears on both the sire and dam side of the pedigree, you color them in the same color. And you use a different color for each individual dog. And so this way you can see very easily where the line breeding is going on in that pedigree. And what we see is that grandparent Hot Penny Carib Weekend Warrior is the grandsire on the sire side, and a great-grandsire on the dam side. So that's like the example that I just used before. We've got 50% for a parent, 25% for a grandparent, 12.5% for a great-grandparent. So he's going to give us 25 plus 12.5 is 37.5% of his genes are going to be shared by in Roy's pedigree. And we have other individuals. If an individual only appears behind a dog that you're line breeding on, then you're not really line breeding on that dog. You're only line breeding on the half of the genes that got passed on to its offspring. But if that individual also appears behind new individuals, then that individual is actually being line bred on as well. Okay, so in 5 generations, the inbreeding coefficient for Roy is 11.9. Within 6 generations, the inbreeding coefficient or homozygosity is 26.9, and your all-generation coefficient is 30.5. So, and again, that is the average for the breed based on embark and based on the pedigrees that we're looking at. And if we look at the pedigree analysis, we find that Hot Penny Carib Weekend Warrior, 37.5% blood as we calculated. He appears first as a grandparent in the 2nd generation. He appears 2 times in the pedigree. Bailey of Bothcanar, 32.4, the average across all your bearded collies. And you're not going to be able to get away from that. Every mating, whether it's a line breeding or an outbreeding, is going to have 32, 33% Bailey because that's where he is. He's everywhere. Okay? He doesn't appear till the 10th generation, but appears 9,685 times in this pedigree, in this database, and therefore contributes 32.4%. Bretani of Bothcanar also doesn't appear until the 10th. So Bailey was born in 1948. Bretani of Bothcanar was born in 1952. It's a bitch. She appears 2,677 times, starting in the 10th generation, contributes as much as any grandparent. And you need to think about how much each time she appears contributes. So if the 2nd generation is 50% and third generation is 25 and 12.5 and 6.25 and 3.25 and 1.56 and 0.76, and then go back a couple of more times, it's an infinitesimal amount that they pass on in those early generations. But when you add them all up, it's a high contribution. Then you get Fiddler Bound to be a Star, who was line bred on, appears 3 times, starting as a great grandparent, and hold on. And then you've got Ridgway Rob, who was born in 1953. He had 56 offspring. Bailey had 14 offspring. He wasn't a prolific dog, but he's behind everything that you've got. Hot Penny Blue Blossom appears in the 5th generation, appears 10 times. So that's more of the purposeful line breeding. He was born in, she was a bitch, was born in 76, had 19 offspring. Osmart Bonnie Blue Braid contributes almost 20%, was born in 65. A very prolific dog, 415 offspring in the database. Bravo, Chantel, Hot Penny Moon Shadow is more of your line breeding, appearing in the 4th generation. Then you've got your background inbreeding here. The next pedigree is Sweetwater's Pink Ribbon. It's a bitch, born in 2009. Anyone recognize her? Call name? Ribbon. Okay. So Ribbon had only 4 offspring. Okay, but here is her pedigree, and as you see, she's relatively outbred. She doesn't have a lot of common ancestors between the sire and dam side of the pedigree. So her inbreeding coefficient at 5 generations is 1.1. At 10 generations is 19.6. And her all-generation inbreeding coefficient is 24.3. So she's about 5% down from your average in all-generation inbreeding coefficient. And so it's not surprising that her pedigree analysis is all about the background inbreeding in the breed. So her most influential is Bailey at 32.9. He appears over 21,000 times. Bretani of Bothcanar, Ridgway Rob, Osmart Bonnie Blue Braid. And the closest individual that actually is line bred on doesn't appear until the 5th generation is Potterdale Philosopher. I'm not sure that I've got him in here, but he appears 21 times starting the 5th generation, contributes more than a great-grandparent from the 3rd generation. Okay, so that's what an outbreeding looks like in your breed. And all of your dogs are going to have these numbers, but if you're line breeding, you'll also have some individuals that are going to pop up, further up the line because they appear due to purposeful line breeding. Okay, your last pedigree is Pentangle's Captain Jack. Anyone ever hear of him?
It was mine. Yeah.
Okay, and his call name?
Jack.
Okay, figured that. Born in 2001. He actually has 5 off.
He's born in 2008.
Okay, then I wrote it down wrong because I was getting it off the database. And he has 5 offspring in the database. He was not bred a lot?
He had 2 litters.
Yep.
He had 14 total.
Okay, so in the database, of dogs that reproduced out of him, 5 were in the database. And so he has a breeding where his grandfather was also a great-grandfather on this side, but these are his 2 litters that he was bred. You say he was bred twice? Yeah, so he was bred to this bitch, Pentangles Kiss Me Now, and I'm sorry, it's the same one. I'm sorry. So because these are the same ones here, even though Pentangles Kiss Me Now does not have a lot of line breeding behind her, so this individual here is actually a full sibling to Pentangles Forever Young. Okay, so he was bred to his sister's daughter. So this is an uncle-niece mating. And that's the mating that produced him. And so, I confused things here. That this is Britannia's Bobby Dazzler might have had more matings than just that one there. So it's an uncle to niece mating. And just that mating alone contributes 12.5% to the inbreeding coefficient based on that relationship. And then adding other line breeding that's going on and the other sides of the pedigree is going to increase that number. So based on 5 generations, it's 18.2. So it's the 12.5 plus the additional percentages from these guys that make it 18.2. 34.9 based on 10 generations, 37.1 based on all of the generations. So this is a line-bred dog, okay, higher inbreeding coefficient than the average of the population. And therefore, his pedigree analysis, Britannia Bobby Dazzler, 37.5, and Pentangles Kiss Me Now. So these are the 2 individuals from that mating, the parents of the uncle and the aunt on the bottom there appear twice in the pedigree. Bailey then at 32.6, over 17,000 times, starting the 9th generation. Shilstone Charlie Charcoal appears 3 times, starting the 3rd generation and down. So this is what a line-bred pedigree looks like. You have close relatives here. You've got background here, background there, line breeding here, background there, line breeding here, and so forth down the line. So that's what the pedigree analysis is. And if you think you're line breeding on certain individuals, these types of calculations will tell you who you're actually line breeding on in the short part of the pedigree, as well as the background and breeding in the back part of the pedigree. The last thing we need to understand from this part of the talk is that the number of generations that you calculate your inbreeding coefficient on in your pedigree analysis, not necessarily your embark number, but on your pedigree, depends on how many generations you're looking at in the pedigree. So for the 3 dogs that we looked at here, Roy, Ribbon, and Jack, if you're only looking at 2 generations, Roy and Jack already have, there's the 12.5 from the uncle-niece mating. Roy actually was a half-uncle, half-niece mating because it was only one of the parents that produced that mating. So actually it's 6 1/4 that contributed, and that's averaged up to 3. And there was a little bit there to average it up to 3. And then as more individuals are added, we get to that total. There was no line breeding on Ribbon until the 5th generation, where it starts in and builds up. And then with Jack, we built up from that uncle-niece mating and went up here. And another thing that you can see from the database is that there's not a lot of background inbreeding that gets added to your pedigrees beyond the 12th generation. So we went up a 10th here from the 12th to the all generation, but we're the same on both of these pedigrees from the 12th to the all generation. So even on a complete pedigree database, most of your line breeding is within 12 generations of the dogs that you're looking at here. But the depth of pedigree that you're calculating those coefficients on does matter. You can't compare a coefficient on a pedigree based on 10 generations to a dog with all generations because you're looking at different populations there. Okay, so now let's talk about what this actually means. Are absolute levels of breed homozygosity, or COI, and differences in homozygosity between individual dogs important? Yes or no? So is the absolute level of homozygosity in your breed and differences between individuals? You look at one dog that has a COI of 23 and another one of 32. Are those differences important? All right, so 89% of you say yes, that's important, and 11% of you say no, it's not of importance when you're looking and comparing pedigrees to each other. Okay, so the next question is why? If you felt it's important, why? If you feel it's not that important, why? Don't be shy, it's anonymous. Selection ability may be able to reduce the level. So is that a goal, to reduce the COI of our matings? Is that a purposeful goal that we need to be doing? Absolute number is not important. Impact on opportunities to create health issues. To help expand the genetic diversity. Okay, I don't see anyone else typing. So let me go up a little bit. And we will address these, but I just want to say a couple of things. Make that go away. Okay, selection ability may be able to reduce the level of the COI versus absolute number is not important. So we'll talk about COI, and should we use COI as a selection indice to add a circle that says I want low versus high? Impact on opportunities to create health issues. For breed-wide health issues in your breed, the genes have already been dispersed in your breed, and we'll talk about that later. So the chance of producing an Addisonian or an SLO dog based on a line breeding versus an outbreeding are going to be the same, because those genes are way in the background, and it doesn't matter whether you are, you're line breeding or outbreeding, the chances of collecting genes are going to be the same because they are dispersed. And because in reality, the true homozygosity, if you did whole genome sequencing, that number is absolute. You are absolutely measuring homozygosity. Because EMBARK uses a SNP chip, which is genetic markers that are at sporadic intervals across the gene pool and not measuring every single gene, it's an average. Okay, and can averages be off? They can be, there's a statistical amount that's going to be off. And that's why they're fudging on the answer. But the true answer should be no, that homozygosity, if you could calculate it accurately, will differ between litter mates. And one with 6% has more homozygosity with 60% more has more homozygosity than the other. But again, we're looking at estimates here, and that's what we're looking at. And the true homozygosity of individuals within the litter, a 6% variation is probably common. Okay, and if you really want to break it down and get really nerdy about it, if the phenotype of those individuals more mirror individuals that you selected for, you'd expect there to be more homozygosity. And if the phenotype of an individual does not necessarily represent the line breeding that you did, you'd expect there to be more heterozygosity because there's more variation that you're seeing in the phenotype. And these are all the subtle little things that we can deal with. But in reality, the percentage from if you're breeding by numbers, by a COI, what you're actually selecting for is the number and not the traits that you need to be selecting for and against. And that's the most important message that we're going to pass on here. And now let me move on. To help expand genetic diversity, you'll find that the COI has nothing to do with genetic diversity. Okay, it only has to do with the relationship between the sire and the dam. It's got nothing to do with your gene pool. It's only two individuals and how well they're related to each other. So nothing to do with the diversity, and I'll show you and explain that. And on opportunities to create health issues, as I said, the health issues that are common in your breed, those genes are dispersed. So the COI has nothing to do with the expression of those health issues. If you have a really tight mating and you come up with a disease or disorder that is not common in your breed, yes, that's possible. You created that due to homozygosity for a very rare gene that maybe was one dog in the pedigree had it and you line bred on that and you concentrated the genes of that dog. But those are the rarer things that you would see in that regard. Let me move on and explain more of that with these pictures here. And all these concepts are in the different articles in the handout, especially the first two articles in that handout there. In order to understand about breeds, you must understand about breed evolution and how those breeds were created. The development of breeds occurred through artificial selection for body type, color, coat type, behavior, and conformational aspects. Those are all the things we select on, okay? And that we're creating homozygosity on those particular things. Body type, color, coat type, behavior, conformation. All right? As breed lines became more specialized and the stud books closed, and now we have registries like the AKC or the Kennel Club, those who did not conform to the standard were removed from breeding. So if you're not reproducing to the standard and to the quality that people want, you're being discarded. And as we know, a very small portion of the population reproduces with each generation. So it's very important who you're selecting for or against in that way. Studies of dog breeds estimate they lose on average a third of their genetic diversity through breed formation. And I'll tell you that they're wrong. Okay, it's more than that. You're losing a lot more than that when we really look at the numbers and look at individual breeds. So here is an average pedigree of a bearded collie based on one of my programs. And so this is the pedigree that you're used to looking at. Here's dog X, sire and dam, grandparents, great-grandparents, and so forth. These are the founders of the breed. So here's Newtown Blackie and Dandy and all these dogs back here are the founders. And so as a breed develops, you have breeding going on. There's no stud book. You've got dogs that are performing and herding properly and they're being used. The ones that are passing on those traits are being used. The ones that are not are being discarded. And then you're trying to hone in on a phenotype, on what they look like. And so they develop a standard. And so this goes on for many generations until the stud book is closed and everyone's reproducing uniformly. And then you go through this population expansion phase where more and more dogs are being bred and that population grows. And in reality, the entire population of bearded collies, this line goes all the way up here and this line goes all the way down there. And the only reason we have this somewhat diamond-shaped pedigree here is because we're only looking at one individual of your breed and that individual's pedigree and who contributes to it. So all the other dogs in your gene pool that are not contributing to this dog are not being counted here. But you can see all of the relationships and the crossing back and forth that goes up that mixes the genes of your dogs in the background. Any selection over generations will create homozygosity or due to uniform purposeful selection for breeding goals. So when you're selecting, you're creating homozygosity, higher COI. If you're selecting for the best things in your breed, you're creating homozygosity. That is your goal, not to increase your COI, but to increase the quality of your dogs. Diminishing frequencies of undesirable genes is a loss of genetic diversity. Okay? If you're selecting against dogs with diseases or that do not have conformational traits that are desirable, you are losing genetic diversity. And so for those that say, I don't want to lose genetic diversity, well then you shouldn't be selecting, because selection by its own purpose creates homozygosity. Any selection causes a loss of genetic diversity. This loss is not detrimental to the population if it is directly related to increasing its superiority. And that's the bottom line about selection and about COI, is that the COI does not necessarily represent health, it represents your purposeful selection. Breed-defining genes would be expected to become homozygous due to selection over time. These include breed-selected traits for size, coat color, texture, behavior, skeletal morphology, and other traits. So all of the things you're selecting for, we expect them to become more and more homozygous as it breeds true in your breed. Even without close line breeding, selection for positive traits will increase their homozygosity, having originated from distant ancestors. So even if you're outbreeding and you don't believe that you're line breeding or contributing to more homozygosity, by selecting for the best quality dogs and the best performing dogs, you're creating homozygosity for the genes that cause those things. All right? So modern breed population statistics, when you calculate it out, give you a high average inbreeding coefficient or homozygosity. And this is what the molecular geneticists at Embark and a lot of other places, they'll look at 30% and say, oh my God, that's a high number. Because compared to to natural species, those numbers are a lot lower. But natural species are not undergoing artificial selection the way that breeds do. So breeds cannot really be compared to natural species in terms of the molecular genetics. We have a low effective population size or a limited number of founders that the breed is based on, high average relationship coefficients to influential ancestors. Every breed has a Bailey-Abothkinar. Every breed has an ancestor that, more than one ancestor that contribute 15 to 35% of the genes to the breed and appeared very, very far back in the pedigrees. Every single breed has that. You're not special, and it's not that Bailey is an outlier when you compare all other breeds. Everyone's got that. And hopefully it's dogs that genetically had really, really good genes that they passed on. And that's why they contributed the way that they did. These are necessary and expected consequences of breed formation and evolution. So this is absolutely necessary to purebred evolution in that regard. This is not a bearded collie. This is my dog Smitty, who's long gone, but he was my first master hunter, so he got to sneak into the slide set here. That's a live bird he's carrying in his mouth. You know, you guys can talk about, look at all the sheep that got into the pen, but I can talk about the birds that my dog brings back unharmed. Homozygosity is not inherently correlated to impaired genetic health, nor does it need to be artificially controlled. So one thing in that first article, which was actually presented in the proceedings of the Parent Club Conference, the Canine Health Foundation Parent Club Conference, which only took place a couple of weeks ago, it says in there that, you know, I showed you that decreasing 10-generation inbreeding coefficients shows a good gene pool where you're utilizing the breadth of your gene pools. And so some people will say, well, if decreasing inbreeding coefficients is good, then we should select for lower numbers. We should select for lower COIs. But it's not the same thing. Okay, so you know it's something that happens inherently because you're utilizing the breadth of your gene pool. If you're just selecting for that number, you're going to select the wrong dogs, and you're not going to maintain and improve the quality of your breed, which is what purposeful selection is about. So you don't need to artificially control that COI and say, I need to know what that COI is, and it must be below the average of the breed. You're limiting the good dogs that can contribute to the quality based on what you need are. So healthy breed gene pools require expanding or large stable populations. So that's really what gives us genetic diversity, is expanding a population. If in each generation we have more dogs to choose from, then the average COI between each mating is going to be lower from the previous generation if our population is expanding or is a large stable population. That's what genetic diversity is about. It's about breeding and maintaining a population and producing more dogs. And the more dogs and the larger the population, the average mating COI between individuals will go down with each generation, and that's what we're looking for genetic diversity. It allows for the creation of new family lines, it allows for within breed diversity, and population contraction can cause the loss of breed diversity and quality breed lines. So one thing in those articles we talked about, because we know that registration numbers from the 2000s, the past 20 years, have gone way, way down because of economic reasons. And hopefully we didn't lose a lot of kennel lines in that process. And when people kept breeding, they bred different individuals from different backgrounds to maintain the breadth of your gene pools, because that's what keeps diversity going. It isn't the absolute number of dogs, but the representation of all the areas of your gene pool, of the quality dogs in your gene pool. Selection and breeding animals should represent the quality traits and breadth of pedigree background. Quality lines should not be abandoned. If someone's retiring from breeding and has a quality line, hopefully there are individuals who has that breeder's dogs and descendants who are continuing to breed them so that those lines are maintained. So let's talk about the popular sire syndrome, because that's the #1 cause of decreased genetic diversity in breeds. And so this is a geneticist's representation of a breed gene pool. Circles are females, squares are males, horizontal lines are matings, vertical lines are offspring. And so we have this, let's say this is a diverse gene pool based on this figure here. And then all of a sudden a male comes along and everyone oohs and ahs and says, oh my God, isn't that dog magnificent? And they start breeding to that dog and they like what he's producing. Some more individuals from all sorts of different areas of the gene pool breed to that dog and they like what they're seeing, and and the dogs are winning, and then they start line breeding on those dogs. And what happens with the popular sire is that very rapidly his genes are distributed across the breadth of your gene pool within 1 or 2 generations. And that's what a popular sire is. And so what that does, it is the single most influential factor in restricting gene pool diversity. It quickly disseminates his genes throughout the gene pool, and here's the key, without the benefit of evaluation over time. They like what they see, they like what he produces in 1 generation, but we don't know what he carries when they start line breeding and going back to him, what is going to be produced there. So it's the evaluation over time. And it causes the loss, an insidious part of the popular sire syndrome is it causes the loss of other quality male lines that should be contributing to the gene pool. There's only so many quality bitches that get bred in each generation. And if a large proportion of them are all going to 1 dog or 1 kennel line, you are sidelining and not utilizing other quality males from your gene pool to propagate that entire gene pool. And the breed truncates on a single line. And that's the problem with the popular sire syndrome. The popular sire, and some people say, well, wait a second, Belly Bothkinar contributes 33% to every single dog. Why can't mine? All right? But a popular sire is different than an influential ancestor. An influential ancestor's contribution is continually evaluated through its descendants, who have to compete with others for breeding status. Every generation, those descendants need to compete with other dogs and be chosen to say, you're the one that's of better quality, I'm going to breed you. And that's how that influential ancestor becomes and maintains their influence, by producing quality generations and generations down the line. If a popular sire, you're not doing that evaluation. You don't have that to evaluate. And if a popular sire is found to pass on deleterious genes, and all of a sudden people 2 or 3 generations are going, wait a second, we're seeing this new disease come up, we're seeing this bad thing, consistently coming from 2nd and 3rd generation descendants of that dog, we need to back away from him. And what happens is, if you need to back away from him, you're backing away from all the quality dams that he was bred to as well. So you can lose an entire generation of quality dams if you need to select against a popular sire or a dog that several generations down the line is just, we recognize now that he's not producing what we really want to be utilizing. So that's why we really need to limit popular sires and how much we breed to each individual. And there's many different ways of doing it. I know it's very emotionally rewarding to have a dog that everyone wants to breed to, and I've had that with our some of our dogs. I had one dog that his first litter at a national, 1 girl, 1 best in sweeps, and the other girl won best puppy in the national. And these were puppies, okay? And everyone came to us and said, you know, we want to breed to Jones. Jones was Smitty's litter mate, and Smith and Jones. Anyway, so Jones was man in black, and Smitty was back in black. They were born the year of the second version of that series, and of course, you got Tommy Lee Jones and Will Smith. But anyway, so Jones's second litter had already been bred and wasn't even born yet. And people are coming to us and saying, we want to breed to Jones. So we just told them, which was not a lie, that Jones is with a field trainer going for his senior hunter title. And so he's not available right now because we wanted to see what else he produced and to slow that down a little bit. So it's really up to the stud dog owner to say, you know, we've got a couple litters, let's evaluate what we've got, and then we'll do some more. You're going to freeze semen on these guys. You can use them long term in the future, you know, once you see what you've got. But it's important to slow it down when everyone is scrambling to go to that popular sire. So to finish up this half right now, because I'm running a little slow, diseases and disorders we'll talk about, and pay attention, what I call the dark side of breed development. All individuals carry some deleterious mutations. Quality individuals who propagate will also propagate their deleterious mutations. Everybody's got some. These can cause breed-related disease if they're disseminated and increase in frequency through the founder's effect. Breed propagation must always include active monitoring and selection against genetic disease. Without this selection, the genetic health of the breed will decline. The genetic health of dog breeds is not a direct function of homozygosity or heterozygosity, so it's not based on COI, but of the accumulation of specific disease liability genes. That's what causes disease, specific genes, not a COI number. And so for breed maintenance, in response to perceived concerns with genetic diversity, some advocate for homozygosity testing and species survival plan type of outbreeding programs. Where you're breeding based on a COI, you must breed for the lowest possible COI. And this is what was created for species that are endangered, where you have a very limited number of individuals in the species, and the whole purpose is to produce viable offspring. Okay, it has nothing to do with anything quality or selection-wise, and so because homozygosity of deleterious genes can cause disease, you're always going to outbreed with species survival plans. The whole purpose of those plans. It's completely different from what we're looking to do with dog breeding. So recommendations to only outbreed homogenizes the breeds and erases the genetic difference between individuals. So if you take the most unrelated individuals and breed them together, their offspring, those lines are now related. Now you need to find a third line for the next generation to breed to that's the least related. Now those three lines are related. And then you need to find more and more that's unrelated. And the bottom line is, once you incorporate all the lines, everyone's related, everyone's homogenized in the middle of the gene pool. All right? What creates selection is differences between individuals. I want a dog that has this, but doesn't have that. If you mix and homogenize the entire breed, you remove those differences. You don't know where the good genes are that you want or the genes that you want to get rid of, because you've mixed and shuffled everybody up, and now everyone appears the same, and you can't have selection without differences. So completely different system, but this is what diversity breeding advocates are looking for. And you're getting that from your Wisdom Health Optimal Selection, you're getting it from Embark, you're getting it from Dr. Peterson's diversity indices from UC Davis Genetic Laboratory. And so where they're telling you, you must select for the lowest COI. And what I'm telling you is, these guys especially are commercial companies, they have to sell you something. And it's easy for them to sell you on COI because people believe it and are going to utilize it, and they'll pay money to get more of their dogs tested. But you have to understand, just because they could compute it doesn't mean that it's importance for what you're doing in trying to create better dogs. None of the types of matings, inbreeding, line breeding, outbreeding, change the frequency of defective genes or their dissemination. If you have 4 dogs that represent the entire population of your breed, and these 2 dogs are somewhat related, they're in a line, and these 2 dogs are somewhat related, they're in a line, but they're unrelated to the other 2 dogs, okay? If we breed outbreed and produce dogs that are least related by breeding those together, you're going to have low COIs. Okay? If we line breed on these two lines, you're going to have high COIs. Have we changed the genes of your breed? No, we haven't changed anything. It's the same genes. It's just distributed differently in different dogs. It's got nothing to do with genetic diversity, zero. Genetic diversity has to do with selection, who you're breeding, not who you're breeding to. And that's where the importance lies in selection. Outbreeding will not change the frequency of deleterious genes. For dispersed breed-related genes, so if we have breed-specific diseases, COI has nothing to do with whether you're going to be affected or not, because those are already dispersed. So whether you're outbreeding or you're line breeding, the chance of getting that disease is the same. But it's not the same if you know who has those diseases behind them, who's produced those diseases, who has those diseases, where you're actually selecting against the genes, not just the number. Affected individuals will be produced in a random fashion if you're always outbreeding. The diseases will just pop up at random. So if you want to know what that looks like, when I talk to veterinarian groups, we look at our cat populations. 95% of our cats are random bred, and only 5% are fancy cats or pedigreed cats in breeds, okay? But we see the most common genetic diseases in cats every day in our practice, feline bladder disease and some allergies and things like that, okay? Because they just occur randomly. So they don't occur with less frequency because they're outbred, they just occur randomly. Molecular geneticists have discovered the tools to identify homozygosity, but these are tools. They are not the goals of breeding. And so we need to understand what's a tool and what's actually a goal. And if we utilize the tools as goals, that's where we will go astray. All breeds are inbred with many different parameters, causing changes to their homozygosity and genetic diversity, depending on the matings that you select. None of these have to do with the health of the breed or selection against specific health or diseases or liability genes. Recommendations to increase the diversity of the MHC haplotypes. We'll talk about that a little bit later when we talk about the autoimmune diseases in your breeds. And no breeds has general limited MHC diversity or homozygosity of the MHC had been shown to impair breed immunity or cause genetic disease. It's untrue if they're telling you this, that selecting for heterozygosity MHC will decrease the frequency of disease. Absolutely untrue. In all studies of autoimmune disease, including all the diseases that your breed have, specific MHC haplotypes or disease-related genes cause the disease. So just like every other disease, it's specific genes that cause the disease. And if you carry those genes, you get the disease or get greater liability for that disease or not. It has nothing to do with homozygosity or of genetic diversity in the MHC. So to finish this half, selection for heterozygosity selects against the good homozygosity that selection causes. If you're saying, I want heterozygosity, I don't want homozygosity, then the only thing you can do is select against the good things that have created homozygosity in your breed through generations. It blindly increases minor allele genes and frequencies in chromosomal segments. So also the Mars optimal selection says in your breed, there's a high frequency piece of chromosome and there's a low frequency piece. We must increase that low frequency piece and decrease the frequency of the high frequency piece. And it's just as likely that that piece is a low frequency due to generations of selection against a specific trait or disorder. And by blindly saying, not knowing any of the genes that are in that section there, but saying we need to increase that one, and pay me and we'll tell you which dogs have that one, is completely against what you're looking to do for your breed and totally illogical for selection. So genetic diversity is breeder diversity. It's the varied opinion of breeders as to what constitutes the ideal animal and their selection of breeding stock that maintains the breeding diversity, the breed diversity. If some of you like to line breed on some lines, others want to line breed on others, someone else wants to outbreed, someone wants to bring something in that they don't have, so they want to outbreed in this generation, and then they get it and they want to fix it so it reproduces uniformly so that they line breed in the next generation. It's everyone doing something a little bit different that creates that breed-wide gene diversity. And if you have an expanding or large gene pool, then your COIs will go down naturally, not due to purposefully lowering that number and ignoring the selection that you're supposed to be doing for quality and for health. When breeds have issues with genetic disease, the only way to improve their gene pool is through genetic screening and selection against specific diseases and liability genes. Moderation away from extremes that cause disease should be a guiding principle in breeding and judging. You don't have many extreme conformation issues that a lot of other breeds have. Too big, too small, too many wrinkles, too much angulation, too much of a smushed in face. So luckily you don't have breeding for extreme conformation as an issue for your breed. Pre-breeding health screening should become as universal as equine pre-purchase exams. So this is just a lead into the second half in terms of if you don't know what you're breeding, then how can you actually do selection? So each of your prospective breeding dogs has to be evaluated for their strengths and evaluated for, what are their faults. And I know none of our dogs have faults, but we really need to evaluate that. And we need to do our health screening, our hips and our eyes and our thyroids so that we know what we're breeding. At least then we can make decisions. It may not completely eliminate a dog, and we'll talk about that in the second half, but we need to at least do it with our eyes wide open so we know what we're utilizing for breeding. So my last slide, breed maintenance requires avoiding popular sire, utilizing quality dogs from the breadth of your population to expand the gene pool, monitoring genetic health issues through regular health surveys, doing genetic screening for breed-related disorders, participating in open health registries to manage genetic disorders, and constant selection for quality and for health. Okay. Welcome back, everyone. Thank you. Actually, the timing, we're doing pretty good because in actuality, because of the quality of the Beacon database, we had a lot more information to provide to you based on the pedigree analyses and on the molecular genetic analyses. And in terms of the genetic disease issues, you have fewer complicated genetic diseases genetically to deal with and to explain what they are and how they're inherited. So in actuality, this is going to go a little bit faster and smoother for the second part, and so we're really good on time. Okay, so developing a healthy breeding program. So that's what we're all interested in. So what are our breeding goals? To maintain and enhance the quality of the breed. That is our number one goal for breeding. And as a veterinarian and as a geneticist, a lot of people look at me and say, well, isn't health the number one thing? There are plenty of healthy mixed breed dogs out there. Okay, they're not bearded collies. We want a quality bearded collie, and that has to always be your biggest goal. All right? Maintain and enhance the quality of the breed. Do not limit genetic diversity of the population. So utilize the breadth of your gene pool in selecting your mates. And then genetic disease control, not that it's not important, but this goes along with maintaining the quality of the breed. So what are the goals of genetic disease control? Do not produce affected animals in your next mating. Pretty simple. Right? We want to produce healthy puppies that will be healthy for their entire life, since a lot of genetic disorders are their age of onset is a lot later on. It's not when they're just born. And then secondarily to that, we want to decrease the frequency of carriers of defective genes in the population, because as carriers accumulate in the population, that limits our breeding choices. And there are some big breeds where the breed club has decided that you should only genetic test your males and not your females. And therefore, as long as you're only breeding normal to carrier, you will never produce affected offspring. And that is true. But you're producing 50% carriers. And 50% is likely much higher than the frequency of the defective gene for that and those conditions in the gene pool. So you're actually selecting with those matings for higher frequencies of carriers. And since you can't breed carrier to carrier, I can't breed to the dog I want to because it's also a carrier, and my dog's a carrier. And then I want to breed to another dog, and they're not a carrier of that gene, but there's another testable gene in my breed, and they're a carrier for that. So by increasing the frequency of carriers, it limits your choice. It's not limiting the health of your litter, but your choice in selecting the best possible mates in your mating. So we want to decrease the frequency of carriers of defective genes, either through selection, if we don't have genetic tests, based on related individuals, or if we have carriers, you want to breed your quality carriers to normals and replace them with a quality offspring. And we'll talk about that. So genetic screening and genetic testing. So what genetic screening do you do in your dogs? Free-form answer. What genetic screening, so not just DNA testing, but what kind of genetic screening do you do in your dogs? For what diseases, conditions, whatever? Hips, eyes, and thyroid. Hips, elbows, eyes, and thyroid. And there's your chick right there. OFA, hips, thyroid, and eyes. We'll talk about it, but elbows is an optional. Those are your requirements. Hips, eyes, elbows, thyroid, and Collie eye anomaly, genetic test. Thyroid, hips, eyes, heart, and elbows. Hips, eyes, thyroid, and elbows. So we're pretty much concentrated on the disorders that are significant in your breed that we want to select against, Collie eye anomaly. Someone had heart in there. Screening for normal hearts is a good thing. Not that you have a high frequency of heart diseases in your dogs, but it's always nice to know that you've got a normal heart on a dog or bitch that you're going to breed. So the requirements are the minimum requirements. It doesn't mean you don't test or select based on other things as well. Okay. So there are tests of the genotype, which are direct DNA tests for liability genes, where you're actually looking for the gene itself and you're looking for a test result from a molecular genetic testing company. There are tests of the phenotype, which primarily identify clinically affected individuals. So if you're doing a hip radiograph, if you're doing elbow radiograph, if you're doing thyroid, those are all tests of the phenotype. They're not specific tests for genes. So mainly we're looking at affected versus not affected. And then there's pedigree analysis, which is the identification of carrier risk based on the knowledge of carrier and affected relatives. So if we know that there are a lot of relatives that have Addison's, we have to consider that my dog is at higher risk, probably of carrying genes that can be liability for Addison's disease. Whereas if we don't have a lot of Addison's in the pedigree, hopefully we're not going to be passing on as many liability genes for the disease. And that's pedigree analysis. So there's genetic panel screening, just to talk about that quickly, because this is what the public is doing, and it's what a lot of you are doing as well. You've got the two big companies are Mars and Embark, and you send in a cheek swab on your dog, and it gives you all of this information. So what we need to understand, it's a mutation test result for over 150 different genetic diseases, most of which have nothing to do with bearded collies or whatever breed are being tested. They're breed-specific genes that do not even occur in other breeds, or if they do occur, do not cause disease in other breeds. And we don't have a lot of those confusing things with your breed. Degenerative myelopathy is the most frequent genetic variant, disease-related variants across all mixed breed and purebred dogs. It occurs in between 7 and 8% of every single dog on Earth, but it only causes disease in a handful of breeds. And it's at very high frequency in many, many breeds. And so I have to spend 10 minutes talking about DM and why you shouldn't use a DM test in your particular breed. But because for some miraculous reason, 0% of bearded collies so far have tested to carry that variant, we don't need to worry about it for you guys because you're all testing normal for that gene. It tests for more than 20 traits, including coat colors, coat types, and morphology or conformation. It has those genetic diversity testing indices of COI, MHC, which we'll talk about. It's a cheek swab test costing $130 to $199 per dog, and it uses SNPs, or individual markers distributed across all of the chromosomes. It's not actually testing for genes. It's only testing for markers, and some of those markers are linked to disease to gene variants that can cause disease, but it's not an exact test for those those diseases. It doesn't check for those mutations, and it requires knowledge of what test results are relevant to the tested individual or breed. So less something you needed to worry about, because the common ones that don't cause disease in every dog, your breed actually doesn't carry as much. So we don't need to go into that. And we'll talk about some of those genes. The International Partnership for Dogs, Harmonization of Genetic Testing for Dogs, has a website. Doesn't come up there, but it's in the handouts. This is an international organization that is trying to standardize genetic testing, genetic test results, so that you can look at valid results from around the world and be able to equal the same thing, and see that genetic testing companies are testing for the right things and not the wrong things, because there are some companies that are running tests that say they're testing for something and they're absolutely not testing for that. And so it's trying to get some validation and standardization in the marketplace. So here's the Beacon. This is based on the Beacon Health Registry database. There are 3,309 dogs that had health testing that are analyzed in that registry and that have results. 36.7% of the dogs have their hips done. 19.8% have their eyes done, 11% have their thyroids done. These are the 3 tests to get CHIC certification. We'll talk about what that is in a second. Elbows, 10.3% of you, and this is listed as an optional test for CHIC certification. So what optional tests tell you is that not everyone or a high percentage of the breed has this disease or disorder, but it's still an important disease in your breed. So maybe everyone doesn't have to test for it, but it does occur in your breed, and so it might be a good idea to test for it. And it also informs us as veterinarians in terms of what diseases occur in your breed that we need to look out for. So if I see that hip size and thyroid are big in bearded collies, and I need to pay attention to thyroid in bearded collies, which we don't pay attention to in a lot of different dogs. And if I see that elbow dysplasia can occur in a breed, and we'll look at the percentages later, then at least I know that that's something I need to watch out for if I see a forelimb lameness in a bearded collie. Collie anomaly, the choroidal hypoplasia genetic test, 6.8% of you test for it. MDR1, which is the herding dog multi-drug sensitivity gene, 1.7% of you test for that. And we'll talk about those things. The OFA online health survey only had 180 dogs, and I'll show you that OFA health survey, and I'll show you lots of things on the OFA website that can be helpful for you. But based on the 180 dogs whose data was entered by their owners, 55% did thyroid, 46.9 did eyes, 39.4 did hips, 27.5 did elbows, 27.5 did collie eye anomaly, 15.6 did hip prelims, 15% have donated DNA to the OFA CHIC repository, which is important, and I'll talk about that. And 5% did hip checks from either Penn Hip or Ontario Veterinary College or some of the other hip rating registries. So the Canine Health Foundation is the health arm of the AKC, and they're the ones that fund all the health research and are charged with increasing the health of all dogs, purebreds and mixed breed dogs. And so one thing that they do, since the big thing they do is to fund millions of dollars of research every year, they ask every parent breed club, and so this goes to your health committee, or whoever is designated by your executive board to answer to the Canine Health Foundation, what are the most important genetic diseases in your breed? Okay, and they send that back to the Canine Health Foundation, and the Canine Health Foundation tabulates all of that information to find out what health issues are the most important to the most breeds, and therefore what disorders should have the most funding for grants to study those diseases in that regard. So before we talk about that, since we're talking about genetic disorders, and again, this is anonymous, so type quietly on your phone, what genetic disorders are you seeing in your dogs? What genetic disorders are you seeing in your dogs? Not that, Well, you don't have a lot of genetic tests for liability genes, so it's not that you're going to put in their degenerative myelopathy or something like that. But what diseases do you see in your dogs, realistically? Autoimmune in general, what specific autoimmune diseases? There are lots of them, and you do have several of them, and that's why that is an issue for your breed. Okay. Systemic leukoid onchodystrophy, Addison's and SLO, AS-allele cancer, hip dysplasia, autoimmune hemolytic anemia. Autoimmune hemolytic anemia. Okay. All right, we are going to talk about all those. So, Canine Health Foundation, top 10 health concerns based on the concerns that are most frequent across all breeds. So this is all breeds. Number 1, hip dysplasia. Number 2, epilepsy. Number 3, allergies. Number 4, the first of the inherited malignant cancers, hemangiosarcoma. Hypothyroidism. Lymphoma as the second of the malignant cancers. Gastric dilatation of volvulus or bloat. Patelloluxation, cruciate ligament rupture, which is a genetic disease. It is an acute disease based on an injury, but there's a genetic predisposition to ACL rupture. We know that based on many studies. Inflammatory bowel disease, that's top 10. The next 10, cataracts, osteosarcoma as the third of the malignant cancers. Atopic or inhalant dermatitis is a very specific allergy that is one of the most common causes of allergies in dogs. Elbow dysplasia, immune-mediated hemolytic anemia, autoimmune hemolytic anemia, cardiomyopathy, progressive retinal atrophy or PRA, which used to be number 1 on the list, but we've identified so many PRA genes it's dropped down to 17 now. Mammary cancer, retained testicles, mitral valvular disease. So those are the top 20 inherited diseases of dogs and the canine health concerns. So this is your Beacon Health Registry based on 3,309 dogs. What are the most frequent genetic diseases? And this isn't necessarily telling us the exact frequency. Okay, so no health survey is going to include every dog and give us the exact numbers for frequency for disorders. But if you have a large enough number, it's going to rank them properly. So it's going to rank so the most frequent is going to be the most frequent, and the least frequent is going to be way down on the list. So at least we can use that. So even if these numbers are not exact, we know that relatively speaking, these are the issues. So 8.4% say that your dogs are fearful. So a behavioral issue is the number 1 issue that you guys are listing on your health surveys. Hypothyroidism, 5.3%, SLO, 3.7%, arthritis in older dogs, 3.1%, Addison's disease, 3.1%. So 1, 2, 3, 4. So if your top 5, SLO and Addison's are in your top 5 in frequency and are also in your top 5 in terms of things that you are concerned with. A lot of times I see a breed and they are so up in arms about a fatal genetic disease that occurs at a frequency of less than 1% in their breed. But because it's fatal, it kills dogs, a popular line may have had it and now everyone's worried about it, so it's a big worry. At least the things that you're worrying about are actually occurring in your breed. Because if you're making breeding decisions on something that occurs less than 1% in your breed, and it's not really related to your pedigree, then once again, you're doing inappropriate selection. So these are things that do occur in your breed. Umbilical hernias, hip dysplasia, pyometra, not inherited, but in your health survey, this is an issue for you. And it's because as breeders that are filling out our surveys, we tend to keep our bitches intact. And so you're seeing that at a higher frequency. Food allergy or intolerance. In actuality, food allergy is a very infrequent disease or disorder. Everyone that has allergic dogs that comes into the practice thinks that it's food related and have already changed the diets a couple of times to try to figure it out, and it's almost never food related. But there are food intolerances that dogs can have, whether certain diets or certain ingredients can cause some GI issues. Urinary tract infections are frequently seen in practice. Cataracts, depigmentation. which is interesting to be listed there because there are some genetic diseases that cause depigmentation. There are also some benign conditions, snow nose and things like that, that can cause depigmentation, so that are seasonal. So it's interesting. I mean, pemphigus can cause depigmentation, and that can occur in your breed, but it's a low frequency disorder. And there are other things that can cause loss of pigment that are more benign conditions. Hearing loss, especially age-related, Cushing's disease, and in the health registry, they list age of onset of these conditions, and many of these. Your cataracts, you don't have a juvenile cataract problem, you've got a senile cataract problem. Okay, your deafness is not a congenital deafness problem like Ridgebacks and Dalmatians. It's an age-related hearing loss problem. Cushing's disease, aggression. So here you've got aggression, low on the list, but as a behavioral issue along with fear for your dog, so something to pay attention to. Inflammatory bowel disease. Vestibular disease is actually a benign disease in old dogs. It's called geriatric vestibular syndrome. It's horrible when you look at it. You think your dog's had a stroke. And some veterinarians will put your dog to sleep for you if that's the direction that it goes, but it's the absolute wrong thing to do because greater than 90% of dogs completely recover, some within 15 minutes, and the most extreme it might take 2 weeks for it to go back to normal. The dogs are 95% totally normal once they recover. They may have a slight residual head tilt, but that's about the extent of it. So it's a completely self-limiting and benign disease, but it's not benign while it's happening, and it's very stressful to the owners. But it's an age-related thing. I don't think there's any genetics that's involved with it. Your breed tends to live a long life. If a dog is affected by it at 10 years of age, might come up with it again at 12 years of age, but has no greater propensity to develop it if they've already had it once. It's purely based on age, and the older they get, the chance of getting it goes up, although still an infrequent problem in the breed. Not everyone's going to get it if they're an old dog. Kidney failure, autoimmune immune hemolytic anemia, and then atopy or allergies as a specific disease process at 1%. I think all breeds is much more than 1% for allergies. So based on the survey results, you have it as low there. The OFA has that online health survey of 180 dogs. Arthritis, 8.3%. Other immune-related diseases at 3.8. I don't think SLO was listed as a disease process, although Addison's was, so I think that's probably encompassing some of that. Prostatitis in intact males, hip dysplasia, thyroid, pyo in intact females, senile cataracts, inflammatory bowel disease, food allergy, hemolytic anemia, sterility in males, lipomas, the most common cancer, a benign cancer in all dogs, sebaceous cysts, hemangiosarcoma, ovarian cysts, Addison's, heart murmur, mammary cancer, contact allergy, inhalant allergy. So similar results even with a small population of dogs on the OFA online survey. Okay, the OFA runs the Eye Certification Registry, or ECR, and that used to be the CERF, and the ophthalmologists went from CERF to the OFA about probably 10 years ago now, maybe 8 to 10 years ago, mainly because the people running CERF, they're doing less and less with the data for the ophthalmologists, whereas OFA said, you want to know the age of cataracts? We can give you age of cataracts. You want to know the trends? We can give you trends. And CERF never could do that. They just recorded the data and reported it. So they went to OFA and contracted with them. So OFA now has all the eye data in the registry for you. And between 2015 and 2019, 479 beardies got examined, 68.5% had normal eyes. So cataracts, this is something that the ophthalmologists like to do. They like to call cataracts either significant or significance unknown. And as a geneticist, I got to tell you, cataracts are inherited. Okay, very few are getting milk replacer related cataracts, or if you don't have diabetes as a problem in your breed, you're not going to get diabetic cataracts as a high frequency. So a lot of ophthalmologists will check off significance unknown and based on location of the cataract and things like that. But the bottom line is a cataract, and you need to be selecting against those, because most of these are inherited. So you need to add together here that at some point in a dog's lifetime, in a bearded collie, about 25% will develop cataracts. Now, senile cataracts, who cares? Old dogs can get cataract formation. So at what point do you call it normal or abnormal? I don't know. But the other thing you need to look at with cataracts is that the most significant cataracts are not complete cataracts that block vision in your breed. They're punctate in the front of the lens or in the back of the lens. So those are the most common cataracts in your breeds. They don't even block vision, but they are a cataract, and some of those can lead to complete cataracts. So is it the worst thing in your breed? No, but it's something to pay attention to. PPMs are persistent pupillary membranes, iris to iris. This occurs at about this frequency in every single breed. It is a piece of a fetal membrane in the eye development in the fetus that is supposed to break down and disappear after birth. And in some breeds, you get these little strands that persist. It does not affect vision at all, and so it is irrelevant to the health of your dogs. In some breeds, like the Basenji, a PPM can lead to other causes of blindness, and so they become more important if they're iris to iris. Any other PPM, iris to lens, iris to the back of the cornea, those types of things are significant, but the iris to iris is not. Dystichiasis is eyelashes that are abnormally placed and can irritate the eye and cause ulcers. And corneal dystrophy is a disease where the cornea gets some clouding or some opacity in the cornea. And in most dogs, even the breeds that have corneal dystrophy, it's pinpoint dystrophies, like the Siberian Huskies can get these, and they're not actually even in the focal plane. So the dogs aren't seeing a spot there. There's a little blurry spot, but it's not in the focal plane of the eye, and it doesn't affect their vision, but it certainly can affect. You're looking at your dog and it's got these white spots on his eyeballs. Is not something you really want. But you've got a little bit of that occurring in your breed as well. ACVO, the ophthalmologists do not recommend breeding any bearded collie with a cataract or with collie eye anomaly or choroid hypoplasia. But you'll notice that choroid hypoplasia is less than 1% based on all of the eye examinations being done in your dogs. So it is not a frequent disease in bearded collies like it is in regular collies or in some other breeds. But it is measurable and something you need to screen for, because it is something that you can test for in your breed. So let's talk about some of these diseases more specifically. So hypothyroidism in the bearded collie, it's a diagnosis of autoimmune thyroiditis, not just thyroid responsive conditions. So that's the first thing we need to understand, is that some veterinarians will treat dogs with thyroid supplementation based on thyroid responsive issues. Okay? If some dogs are obese or have obesity and the owners just can't handle getting some of that weight off, which is bad for them, they'll give them a little bit of thyroid supplementation. Not a complete dose, but maybe a half dose to try to get some weight off of that dog. That's not hypothyroidism. Some reproductive specialists, if a thyroid profile level is not at the average or above for the breed, they will, and a bitch is missing missing pregnancies, they're getting bred and they're not getting pregnant, they will supplement with thyroid and very often can get those bitches pregnant. So that's 50%. So 50% or above on your thyroid profile, which means if you're at 50% or below and you're missing, getting pregnant, they're going to supplement that. That's not hypothyroidism, okay? Poor coat. If you supplement thyroid, you get a more luxurious coat. That's not hypothyroidism. All right, and not necessarily something you want to supplement thyroid on, because that in a normal dog does cause other issues as well. But dogs with measurable autoantibodies against their thyroid glands are affected. That's what hypothyroidism is in your breed and in all other dogs. 4.3% of 793 bearded collies tested by Michigan State University, which is one of the gold standard places for getting genetic testing, for getting thyroid testing done. 4.3% test positive for autoimmune thyroiditis, and the average for all breeds is 7.5%. So in actuality, your breed has less documented hypothyroidism than the average across all other breeds. But the issue in your breed, and we'll talk specifically about the thyroid profile itself, is that 6.6% are testing equivocal. And equivocal means you've got a thyroid profile has a couple of different measurements, but the three most important measurements are your total T4, or thyroid hormone level, based on what's called equilibrium dialysis, or ED. That's the most specific test for T4. Your thyroglobulin autoantibodies, or TGAA, showing that the body is producing antibodies against the thyroid glands. And lastly, the TSH, or the thyroid stimulating hormone level, which is produced by the pituitary to tell the thyroid to make more thyroid hormone. So it's a feedback mechanism. If the thyroid hormone level is low in the dog's body, the pituitary should kick out TSH to say to the thyroid, hey, we need more thyroid hormone, produce more thyroid hormone, thyroid stimulating hormone. These are the three most important aspects of the thyroid profile. If you only have two of them, the abnormal, and one of them is normal, they're going to call it equivocal because it doesn't fulfill all three parameters. And so it's the equivocals in your breed that makes that number much higher than the average at 7.5. So that's something to consider and to pay attention to. So the OFA thyroid statistics are 1,069 because you're registering your thyroid hormone results because it's part of your CHIC requirements. 87.8% normal, only 1.5% are affected, or 16 dogs. So the OFA, if you have abnormal results, a lot of times people are not sending it in. So your normals are going to be normals, but your abnormals, who wants to pay to have an abnormal? Actually, for thyroid, if you send in an abnormal, you don't have to pay for it. It's free to go into the registry, and that way you'll get your CHIC number. But not a lot of people do that, so this is probably underreporting this number. But look here again at the equivocals. Over 10% have equivocal results, and many of those dogs are going to be affected. But it's just at what point they're being looked at to have their thyroid profile done. So that's something that's important to pay attention to. So hereditary autoimmune thyroiditis. The thyroid profile is a snapshot of a continuous disease process. All right? It's a snapshot. It's what the thyroid level is on that day that the blood was drawn. And we need to think about the moving picture of hypothyroidism. So we need to say, at the beginning, the body starts producing antibodies against the thyroid gland. Okay, so you start to get some measurable autoantibodies. But the majority of the gland is normal, so you have normal thyroid hormone levels, T4s, normal TSH. At some point, the amount of thyroid gland that's been destroyed by those antibodies is enough that the T4 starts to go down. Pituitary says, hey, low thyroid, TSH goes up. So that's classic autoimmune thyroiditis. All three indices are going to be in the abnormal range. At the end stage, once the thyroid gland's been destroyed by those antibodies, where the body has been attacking its own thyroid gland and there's only fibrous tissue left, there's no T4 being produced. You have very low numbers. Okay? There's high TSH. But because the stimulation of those antibodies is the thyroid tissue itself, and the thyroglobulin molecules are no longer there, you no longer have the antibodies being stimulated. So you have low antibodies. So you have low T4, high TSH, low antibodies. And the internists used to say, well, 50% of hypothyroidism is autoimmune thyroiditis, and 50% is idiopathic. Idiopathic, just like idiopathic epilepsy, idiopathic hypothyroidism. Idiot, I don't know. Pathic, what's causing it? I don't know what's causing it. That's what idiopathic means, all right? And now we understand that idiopathic hypothyroidism, the majority of those are end-stage hypothyroidism where the autoantibodies are gone. Now, in really sick dogs, they can have low thyroid and high TSH because the endocrine system responds to everything going on in the body, and stress in the system in the body can cause low thyroid. So if we have major disease going on, you can also get low thyroid. But if there's major disease going on, you're going to know it too because your dogs are sick. So the majority of these are going to be autoimmune thyroiditis. So range of 2 to 6 years with peak levels at 4 years of age for those autoantibodies. That's when you need to test. The OFA and most of the thyroid testing places, MSU, they say to get 2 thyroid profiles done on a dog between two years apart, between 2 to 6 years of age. And if both of those profiles are normal, your dog is unlikely to have autoimmune thyroiditis. So that's the screening that I recommend and that many recommend. 2 thyroid profiles, 2 years apart, between 2 to 6 years of age. And that is going to catch most of the dogs with autoimmune thyroiditis. Okay, canine hip dysplasia. So bearded collies rank 148th out of 191. So this is where you don't want to be number 1. All right? So that's a pretty darn good number. You rank 148th out of 191 breeds with over 5,000 radiographs from bearded collies being evaluated. 93.7% are normal, 7.8% are excellent. Average for all breeds is 5.7, so you've got more excellence than the average for other breeds. 64.8% good, 11.4% fair. 5.7% of your breed is dysplastic. Average is 11.4% across all breeds. So yes, you have hip dysplasia. Yes, it's a chick requirement because it's one of the easiest things to get and one of the things that most people think of doing is a hip radiograph, especially on a working breed. 33% mildly dysplastic, 1.8 moderately dysplastic, 0.6 severely dysplastic. And that's just looking at that tail end of that bell curve in terms of you're always going to have more milds than moderates and more moderates than severes because it's tapering off as to the severity of the disease. So you've got far less dysplasia than the average breed, far more excellent than the average breed. So that's a really, really good place for you to be. That's why you're ranked so low on hips. Trends that you want to look at, because that averages every radiograph that's ever been sent to OFA since the beginning. So prior to 1990, you had 8.9% dysplasia, 11.4% excellent based on 1,700 radiographs. Looking at 5-year periods going through, except for this last period where the 5 years haven't been finished yet. You look at the number of dogs being done, a lot of testing being done. Excellence have gone up. Dysplastics have gone down. We went up a little bit here, but this isn't a full 5-year period, so we got a little bit more to add to that level there. So you guys are doing the right thing. Far more excellence, far lower dysplastics. That's what we really look at. You want to see a lot more excellence than fairs. The majorities are going to be goods, okay? But fairs are pretty close to being affected. And fairs genetically differ than goods. The grades, and I'll show you that when we talk about control, the grades of dysplasia definitely represent different levels of liability genes that your dog is carrying. Okay, elbow dysplasia. You rank 92 out of 135 based on almost 1,000 evaluations. 97.2% normal, 2.6% dysplastic. And grade 1, 2, and 3 are the severity of dysplasia. And so as with all other diseases that are polygenic and that are on a population curve, you'll see more of the less severely affected and less of the most severely affected. So this is a very good number. So you have relatively few dogs with elbow dysplasia. You know, the Bernese Mountain Dog is number 1, and almost half the breed has at least grade 1 elbow dysplasia. So it's a bad disease in that breed. The thing you need to understand about grade 1 elbow dysplasia is that those dogs are never lame. They will never themselves suffer from arthritis from grade 1 elbow dysplasia. But when you look at a dog with grade 2 or grade 3 elbow dysplasia, and look at its siblings, look at its parents, look at the parents to its siblings, you'll see a lot of grade 1s. So grade 1 tells you that you're starting to accumulate liability genes for elbow dysplasia. And if you don't pay attention to it, you will start producing the disease where dogs are debilitated and they have to have their elbows fused because there really isn't an elbow replacement surgery, and they will have arthritis the rest of their lives. So it's something to pay attention to. And the fact that your breed is so good with its numbers on dysplasia doesn't mean that you need to ignore it. And so it's an optional on Chick, but to me, if you're taking a 2-plus-year-old dog in and have its hips done, it's not much more to get the elbows done at the same time. Just do it and feel confident and satisfied that your dog's elbows have passed, because you don't want to ignore when it's there and you're not looking for it. Okay, Collie eye anomaly, CEA, is actually choroidal hypoplasia is the veterinary term for it. There are several different aspects of Collie eye anomaly that we can talk about, but the genetic test for it is choroidal hypoplasia, is the CH gene. And it causes an inadequate development of the choroid area of the retina. It's present at birth. It's non-progressive, so it's not something that develops over time. They either have it, they have good vision, they don't have, they have good vision, or if they have it, they could have poor vision. Could have. It's an autosomal recessively inherited disorder. So it's a single gene system, normal, carrier, or at risk. Only 5 to 10% of dogs that are at risk homozygous for the CEA gene will actually develop some vision abnormalities and vision problems or blindness. So it is a poorly penetrant gene in the homozygous state where you have 2 copies. Only 5 to 10% will go blind. But if you're one of that 5 to 10%, that's not a good thing to be. So you want to avoid breeding, and if you have low, if you're a breed that has high frequency, then we start to talk about, do we eliminate all carrier-to-carrier matings, or do we look at other factors that are involved here? But because you have a fairly low carrier frequency, avoiding carrier-to-carrier matings is probably a smart thing to do. And eventually replacing carrier parents with normal testing offspring, which is the recommendation for autosomal recessive disease. Blindness is caused mostly by retinal detachment because of that abnormal retina, and when that retina detaches, it causes bleeding in the back of the retina there, and that also will cause blindness as well. So the genetic tests, 241 dogs have been tested by paw print, 87.1% normal, 12% carrier, 0.8% homozygous at risk. And recognize we're not saying affected, although the genetic testing companies will tell you affected. But if it's affected, you think it's going to have the disease phenotypically when you at what you're looking at. And when these are poorly penetrant diseases, we like to say at risk, because it doesn't guarantee that they're going to go blind. When you say affected, you think they're going to go blind, and then you're making the wrong decisions. So it's an at risk. Embark, 218 have been tested, a lot more normals, less carriers, 0% at risk. More people have used paw print genetics. I think probably more breeders have used paw print to test. Embark tests a lot of pet dogs because that's who they market to as pet breeders, as well as to the breed club members, but a lot of marketing to pet people. So this might be actually show a more, it's probably somewhere between these two in terms of a more accurate representation. But even the at-risk individuals here that are testing, we know from the ACVO examinations that it is far, far less than 1% that they're actually seeing choroidal hypoplasia on the eye examinations. And that's a good thing. So something you should test for, but it's not the most important thing. And homozygous dogs do not necessarily become blind. Only 5 to 10% of them do. So Addison's disease, hypoadrenocorticism. It is an autoimmune disease, an immune-mediated destruction of the adrenal glands. This is your first and most frequent. No, it's not your most frequent autoimmune disease because hypothyroidism is your most frequent autoimmune disease. So it's your second most frequent immune-mediated disease. Typical presentation: lethargy, poor appetite, vomiting, weakness, and dehydration. Onset usually 4 months to several years of age. Treatment with either DOCA injections or oral fludrocortisone. So that's all I'm going to do to talk about Addison's. I'm not here to give you a lecture on how to deal with Addison's disease, but these are the high points of it. It is a complexly inherited disease with an unidentified major recessive gene. So based on pedigree analysis, there is a major autosomal recessive gene that's involved in the transmission based on pedigree analysis of affected dogs. The heritability is 76%. So it's a highly heritable disease where if you have Addisonian in the pedigree, the frequency of other Addisonians is going to be high in related dogs. It's estimated as a frequency of 2 to 3.4% in the Bearded Collie breed. This is based on published articles on Addison's disease in Bearded Collies, based on single population studies like Dr. Oberbauer and Gashoni at UC Davis, as well as Addison's disease studies across all breeds from centers around the world. So research, primarily Drs. Oberbauer and Gashoni at UC Davis. They have done a genome-wide association study, or GWAS, so that uses those SNP chips that has markers distributed across all the chromosomes. And then they looked at 55 cases and 85 controls, so 55 dogs that had Addison's and 85 controls that did not have affected relatives within 1 or 2 generations. So you're looking at dogs that should be relatively clear of Addison's liability genes versus dogs that are clinically affected. They found a significant association to a region on chromosome 18. Okay, so a major association. When they compare all the affecteds with all of the controls, there was a peak with the affecteds on chromosome 18 that is not there on the controls. And it was statistically significant, major peak. There are hundreds of genes in that section that are surrounding that single marker. SNP is a single nucleotide polymorphism or nucleotide change, ACTG, that type of thing. But all it is a marker on a chromosome, and there are hundreds of genes near that marker that could represent. So we don't know yet what gene that is related to that marker. There's also small associations to regions on chromosomes 11, 16, and 29. Okay, so there are other genetic variants on those chromosomes that are occurring more frequently in affected dogs than in the control dogs. All right. Some of these associations may be causative or liability genes that actually cause Addison's disease. Some of these may be regulatory that turn genes on and off. Okay, so they don't actually code for a protein themselves, but they tell another gene that codes for a protein turn on or turn off. So the regulatory genes. To the molecular geneticists, that means if it's a gene that codes for a proton, it's in an exon. If it's a regulatory gene, it's in an intron. But you don't need to know about that stuff. Okay, the bottom line is they add up and they cause that gene. None of these have specifically identified genes yet for this disease in your breed or any other breed. There's no test for Addison's disease yet. What they have found that having more than one chromosomal marker, so of those 4 markers, the very strong marker on 18, and then 11, 16, and 29, if you have more than one of those markers, the risk of having Addison's disease goes up. You have 3 of those markers, it's up even higher. 4 of those markers is the highest, all right? But only 10% of affected dogs had all 4 markers. So not all markers are the same, and how they interact with each other, is one turning on or turning off another gene at the other location? We don't know. But it's certainly important, but it's not strong enough for us to offer a commercial test based on 4 SNPs. That would not be the right thing to do. You'd be selecting against a lot of very healthy dogs that are quality dogs in your gene pool because you think you're selecting against Addison's and you're not. So we really need to identify the genes and figure out what they do to offer you a test for Addison's disease. Another interesting thing is that there was no association to chromosome 12. The MHC or histocompatibility complex, the major histocompatibility complex, DLA, dog leukocyte antigen. So the immunity cluster of genes that we think about with autoimmune disease, there's no association to the MHC for Addison's disease. It is an autoimmune disease. There could be something in the MHC that has to do with it, but we're not getting any hits on it for this disease. So once again, genes for specific diseases are causing disease, and it's not necessarily the location of them that makes the difference there. Still more research needs to identify specific genes. The latest article from their laboratory came out in 2020, Genetic Characterization of Addison's Disease in Bearded Collie. So this is the up-to-date data on the research. Okay, SLO, an immune-mediated disorder causing loss of toenails. Onset between 3 to 8 years of age, affecting 1 to 2 nails, then progressing to all toenails within 2 to 9 weeks. So it starts with 1 or 2 nails that they lose, and then you see a lot of them start to come off. It requires lifelong treatment with oral fatty acid supplementation, omega fatty acids, plus or minus other meds, doxycycline, I got a couple of dogs that are not bearded collies on it, but there are a couple of things you keep them on until they're doing really, really good, and then you pull them off those and you just keep them on the fatty acids and try to prevent them from coming back up again. It's complexly inherited, caused by more than one susceptibility or liability gene pair, so multiple genes involved. So genetic studies, again, Gershoni, Oberbauer, and their group, their latest article was published in August of this year, just last month. There are 2 MHC or DLA class 2 haplotypes that are related. So here the MHC is having a major effect on SLO. All right, so here's an autoimmune disease where the MHC is involved. But so we need to understand a little bit more about the MHC. The MHC is comprised of 3 genes, okay? And so the combination of those 3 genes is called a haplotype. A combination of several genes together on a chromosome is called a haplotype. So all it means is 3 closely associated genes that are being inherited as a unit to the next generation. That's a haplotype. So there are 3 gene combinations that are highly associated with being affected with SLO in the bearded collie. There are additional genes associated with SLO. They're not in the MHC, but when Drs. Gershoni and Oberbauer look at those genes, they're always traveling with these highly associated MHC haplotypes. So they are linked together and probably inherited together. So it's not necessarily independent genes from the MHC, but ones that are getting swept in on a piece of chromosome with the MHC that are causing liability to SLO. Another location on chromosome 17 is also highly associated with SLO and bearded collies. So there's an independent location or marker for genes from chromosome 12 where the MHC is involved. So we've got some MHC genes, and we've got some kind of gene on chromosome 17 that's also involved. But specific genes in this region have not yet been identified. And again, this is only stuff that's been published last month. So they're working on it and hopefully can get you figure out genes and figure out what we can use as a genetic test against this disease process. But nothing is available for that right now. So complexly inherited, multiple genes involved. The MHC is involved, but here again is what's specific. It's specific haplotypes or 3 gene combinations. If you don't have that 3 gene combination, you don't have liability to this disease. It has nothing to do with the homozygosity of the MHC. It's got nothing to do with the diversity of the breed with MHC and how many different haplotypes the breed carries. It's a specific disease liability haplotype or liability gene. Every single genetic disease has specific liability genes you need to select against and select for the genes that do not cause disease. It's got nothing to do with saying you need more diversity in your MHC or you need to avoid homozygosity of your MHC. It's a specific gene itself. So autoimmune hemolytic, so going back to EMBARK, you're going to get that report. And even, so in the report itself, it says, if you look at the wording of it, it's really a vague wording. It'll say that some researchers find that MHC can contribute to certain immune-mediated diseases, and possibly homozygosity, but it's not a full statement. And if you actually listen to Aaron Sams or to Adam Boyko, the founder and the chief science officer at Embark, when they did their worldwide webinar earlier this year, they explicitly said, we haven't linked anything to homozygosity of the MHC. We haven't linked any disease process to MHC diversity. There are some breeds that only have 2 MHC haplotypes in their breed. They have no autoimmune disease. They're probably healthy, and they got that way from selection. And there are some that have 7 MHC haplotypes, and they're healthy. And there are different breeds that have either a small number or a high number of haplotypes and that have immune-mediated disease, but it's got nothing to do with homozygosity or how many haplotypes your breed carries. It's which specific disease-related haplotype is present to cause disease. So that's the basis of that MHC statement. Immune-mediated hemolytic anemia, autoimmune disease where the body's immune system attacks and destroys its own red blood cells. There's a slightly increased female preponderance for this disease. There is equal representation of males and females in Addison's and SLO. A lot of immune-mediated diseases, you have a female preponderance in humans in disease and in dogs as well. So autoimmune hemolytic anemia is one of them. But in SLO, in Addison's, and in hypothyroidism, there's no sex difference in terms of affected individuals. Complexly inherited, no genetic test exists. Dr. Friedenberg at University of Minnesota is currently working to identify gene mutations for autoimmune hemolytic anemia. I'm not sure which breeds specifically he's working on or whether bearded collies are included in that, but it is a multi-breed, a cross-breed study. I want to mention MDR drug sensitivity because this is a herding breed issue, and you do have a herding breed. And only the herding breeds carry this mutation. So ancestrally, a collie type of dog early on was where the mutation occurred and got spread across all the herding breeds on the collie lineage. And you are bearded collies after all. It's ivermectin is the poster child, but there are many drugs that as veterinarians we need to be careful with in dogs that can carry or be homozygous for this disease. It's an autosomal recessive. It causes neurological signs, tremors, seizures, and coma in affected dogs, especially with some of these obnoxious flea pills that are being sold now, which I would never sell. A poison that you're feeding your dog in order so that every flea needs to bite your dog to ingest it to die, and hopefully it doesn't kill your dog. And just to go off topic just slightly, you look at the side effects of these drugs: tremors, seizures, death. Okay, how does it kill fleas? Tremors, seizures, death. Don't tell me it's not affecting your dog and it's totally inert and it's a safe drug. You know, we will find out 5 to 10 years from now what diseases that these drugs cause. But to feed an internal toxin for an external parasite when we have such great external drugs to treat them with, to me, is just a stupid thing. As a veterinarian, I never prescribe these except for Demodex or a couple of other things for a short term. Mutation found in the collie-related breeds, genetic test is available. It occurs at a very low frequency in bearded collies, the MDR1. It's not found in a worldwide survey of 438 bearded collies, along with other breeds. It's a multi-breed survey. It was published in 2011 by Grammer et al. In the Veterinary Journal. But there is a Italian study that included across all breeds that included 10 bearded collies. Can I guarantee they were all purebred bearded collies? No. But 1 out of those 10 bearded collies was a carrier. So is the possibility that MDR1 can exist in your breed? Yes, it's a herding breed. It's a collie breed, okay? Does it occur with high frequency in your breed? No. But if you're running Embark tests, if you're running SNP panel tests, if you're running a panel test from paw prints, you know, you're already paying for the DNA, you're sending it in, you might as well get the MDR test done and be relieved that your dog doesn't carry that. Okay. Lastly, on disorders, primary lens luxation does occur at an increased frequency in your breed over other breeds. Not a frequent disease, but it is something that can occur. It can progress to secondary glaucoma and blindness. Pemphigus is another autoimmune skin disease. causing symmetrical scale encrusting, hair loss, pigment loss to the head, muzzle, foot pads, usually around 4 years of age, and seasonal flank alopecia, a seasonal bilaterally symmetrical hair loss affecting the flank, the back, and the tail. So these do occur in your breed at higher frequency than across all dogs, but not high frequency disorders, but something that you can occasionally come across in a bearded collie. Okay, so that's all the disease processes. This last part has to do with genetic testing, genetic screening, and how to control and select against genetic diseases, whether you have a test or you don't have a test. So let's start first by defining responsibility. If you look up in the dictionary, responsibility is duty, obligation, or burden. So we need to ask ourselves, what is the obligation for breeders to do genetic screening and genetic testing? Breeders are the custodians of their breeds and their gene pools. Above all, do no harm. That might sound familiar. It's the Hippocratic oath that all physicians take. And as a veterinarian, we take that oath as well. As breeders, what is the oath that you should be taking? Above all, do no harm. So breeders should be counseled to use genetic tests for the best interests of their breeds, not to decimate their breeds by making inappropriate decisions, but educated decisions based on genetic screening. What's the expectation of the general public? This used to be a funnier picture before COVID, because I Googled general public, and this is one of the pictures that came up, and I have no idea why, but now it has a more ominous impact. But the expectation of the general public is that all breeders do genetic disease control, and we know that all breeders do not do genetic disease control. And hopefully, since your breed is a smaller population breed and you don't have a lot of commercial breeding of bearded collies, there's a lot more genetic disease control going on in your breed. It's the ethical responsibility and obligation of all breeders to perform the available required pre-breeding genetic health tests on prospective breeding stock prior to any breeding. Not genetic testing after they're born, but before you do your breeding. So health-tested parents for healthier puppies. This is the motto of the OFA. The OFA is now OFA CHIC, the Canine Health Information Center. All genetic disease cannot be prevented. However, we have the knowledge and the tools to improve the genetic health of puppies. And we should be, in an educated way, doing that to improve the health of our puppies. So who's a reputable breeder? One that does genetic screening. If not, find a different hobby or profession. So, this is where if you're not going to do a good job breeding, you need to find something else to do. Okay? This is a responsibility to do genetic screening, is to inform yourself what you are reproducing and not be surprised when it happens. Okay? We're always going to be surprised, but we can leverage our decisions so that those surprises become a lot less common for us. Many health tests can be performed during examination with your own veterinarian or obtained inexpensively at local health screening clinics. So a lot of breed clubs will set up screening clinics where you can get your eyes, you can get your hips done, you can get your elbows, you can get your hearts evaluated, you can have hips and elbows done, you can get temperament testing. There's all sorts of places where you can get everything done, one-stop shopping. There is a health screening clinic database on the OFA website, but the best database is the CavalierHealth.org database. They have committed themselves to put every single health screening clinic in the US and Canada on a list. So you can look up where the screening clinics are. Just Google, it's CavalierHealth.org. And you can get all of your screening tests done. It lists where they're done. It lists what is being done. If you click on it, it tells you which cardiologist is doing it or which ophthalmologist is doing it, what the cost is, who you need to contact for registration. So it's your one-stop shopping for health screening. So managing genetic disease. With dominant genes, so if you have a disorder where only one gene is necessary in the gene pair to cause disease, then you really want to prevent the transmission of that gene. And so for all of the recommendations that I make for controlling hereditary disease, they allow you to utilize the dog that you have and decrease the the chance or frequency of passing on that disease in the offspring. And with dominant disease, it's the only time that we need to say to you, you can't use that dog, or you shouldn't use that dog for breeding. You should pick a close relative of that dog. Even if you don't have a genetic test, affected dogs have that gene and you don't want to pass that on. So you want to replace affected breeding dogs with a normal sibling, the normal parents. One of those parents was probably going to be normal, or prior born offspring. But you don't want to breed and produce more affected dogs, because the number one goal of hereditary disease control is don't produce any in your next litter. And with dominant disease, you can do that. So, here's a late onset disorder. So this male was bred before the onset or before the genetic test was available. He produced affecteds. He's got affected litter mates. Do we have frozen semen on his sire, or his sire available? Is one of the litter mates available for leasing or for breeding, or a prior born normal testing offspring? But do not repeat the matings with dominant disease. With recessive genes, which is the majority of diseases that we see, because dominant genes are easy to control because you don't breed the affecteds and you get rid of it pretty quick. But recessive genes have all those carriers, far more carriers than affected dogs. If you have a test for carriers, you want to breed carriers to genetically normal mates. So if you have a test for carriers, you don't want to eliminate your quality carriers. If it's a quality dog, you want to breed it. You want to replace that carrier parent with a genetically normal testing offspring that equals or exceeds that parent in quality and other aspects, and select against placing more carriers in breeding homes, because we don't want to increase the frequency of carriers in the population. The proper use of genetic tests. Without genetic tests, the effective selection on a gene pool is minimal. We don't know where the carriers are. But once you have a genetic test, if everyone decides not to breed carriers, it can have a significant limiting effect on the gene pool. Because for common, for breed-related disease, the number of carriers is going to be probably anywhere from 8 to 15 to 30%, depending on the frequency of the disease and the type of disease it is. And there's a Hardy-Weinberg equation that some people will use, that if you know how many affecteds are in a population, you can figure out how many carriers there are. But that equation is based on random breeding, and that everybody reproduces. And we know that doesn't happen. We have selection. We have a small percentage that are reproducing. But it does give you an idea that there's a lot more carriers than affecteds. But at any rate, that the frequency of carriers, if you can't identify them, the effective selection is minimal. If you can identify them, you can devastate your gene pool if everyone gets eliminated. So if a breeder was planning on breeding an animal prior to receiving a carrier test result, so this is my next breeding dog, I'm a responsible, health-conscious breeder. I'm going to do my genetic testing. Oh my God, my dog is a carrier. There's no way I can breed it. That's the absolute wrong decision you can make for a recessive disease. You need to breed to a normal and eventually replace that quality carrier parent with a quality normal testing offspring. Each individual is not an eye, a hip, or a heart. Each individual carries tens of thousands of genes, which is each part of the gene pool. You must consider all aspects: health, conformation, temperament, working ability, and making breeding decisions on a single testable gene is inappropriate. This is a quote from Dr. Paula Henthorn at University of Pennsylvania. For recessive diseases, a direct genetic test should not alter who gets bred, only who they get bred to. So let's talk about genetic registries. The OFA used to be the Orthopedic Foundation for Animals. It's still known as the Orthopedic Foundation for Animals. It really, now we are OFA, the Canine Health Information Center. It's not just orthopedic and hip diseases that when the OFA started, that's all it was about. Now it's about all hereditary diseases of dogs. The Chick DNA repository. Because we're short on time, I'm not going to go onto the website, but go onto that website and see all the things that you can do. It's all been redesigned. When you first go on the website, you'll see 3 things that you can look at. The genetic tests for my breed, the Chick requirements, the frequency of genetic disease in my breed for all testable diseases, and what the recommendations are. At the bottom, if you are an owner, you click on owner. It gives you all the owner information you need to know about genetic disease and OFA. If you're a breeder, it gives you all the breeder information. If you're a veterinarian, it gives all the information you need to know as a veterinarian about the OFA. The chick DNA repository is DNA stored on individual dogs for future research. And for true genetic research, you need multi-generational DNA that takes generations to collect to do the proper kind of DNA research. And we're dealing with Addison's and SLO research based on case control studies. We've got these affecteds, we've got these unaffecteds. Doesn't deal with the relationship, genetic relationship of those dogs. It's based on the genes that are carried. But if you do multi-generational molecular genetic testing based on having the parents and the grandparents and all the siblings, that will identify those affected genes, those defective genes so much faster. And so building that bank is really important. Currently, the 72 Bearded Collie DNA samples in the chick repository, 29 blood samples, 43 cheek swabs. Blood samples are the gold standard because if there's a blood sample in there, that can supply DNA to 10 or 15 different genetic investigations. As well as if you have DNA in the repository, as an owner, you still own that DNA. And if a deceased dog, if a test for Addison's susceptibility comes along and you want to know where your foundation dogs lie with that, you can request that DNA, OFA, to send that DNA to a testing center and get your dog tested. It can also be tested on frozen semen, although you don't want to waste semen for testing. But if you've got poor quality semen from a collection, that's semen, they just send it. It dies before it gets to the testing lab, but they can test semen and have a deceased dog identified for that. So I know that there's a lot of DNA at Embark. They're never going to do the types of studies you need to do. They're in it for the commercial purpose of making money. So if something comes along and they find something, that's fine, but they're not supplying grants and looking at specific diseases for your breeds. And it's a random collection. The DNA at UC Davis, that's where Drs. Gershoni and Oberbauer have a great database of affected and controls, and they're doing great research. But if they hit a wall and more modern researchers come up to study those diseases in other institutions, they will not have access to that DNA. They cannot have access to that DNA. There are institutional rules that unless when that DNA was collected, you signed off on a statement that says this DNA can be shared with any other researcher. I don't know that that's something that you guys have done when you donated to those, what the sign-offs were. Then legally, by the university requirements, that DNA cannot be shared, even if they want to share it. So having a repository is important, and I recommend that in your shows, in your get-togethers, and your picnics, that you have a veterinarian or a technician there to collect DNA and send it into OFA Chick and build your repository for future research. OFA, the Canine Health Information Center, the standard of care in health-conscious breeding. Chick is an open health database for breeds. Included disorders are determined by each parent club. Animals can achieve Chick certification based on their required genetic testing, regardless of normal or abnormal outcomes. So if your dog gets a Chick number, it doesn't mean that it's normal for all of those tests. It only means that you're health conscious and you did those tests. And that is what Chick is about. As more testable disorders emerge, every individual is likely to carry some deleterious genes, and we can get beyond that my dog's perfect and yours isn't idea and just say, what does my dog carry? What does your dog carry? Let's figure out how to make the best possible Bearded Collies. So it's not about health normalcy, it's health consciousness. And the Bearded Collie, so we are beyond we're at 7:34. I will be done within the next 10-15 minutes, so just to let you know where we are. Hips, eyes, and thyroid are required. Elbow dysplasia is optional. So if you do hips, eyes, and thyroid, you get a Chick number. Getting the elbows done is a smart thing as well. 569 Beardies have achieved Chick certification. I did a study that took 3 years, 2015 through 2017, the number of Chick certified dogs versus the number of dogs registered in those years, and came up with a breed ratio, number of Chick dogs, divided by the number bred, the individual number of dogs bred in those years. How many chick certified dogs are there? How many Bearded Collies were bred in those years, and averaged it between those 3 years. Your chick ratio is 42%. So 42% of the Bearded Collies that were bred had a chick number and had at least those 3 tests done. That is an excellent number, 42%. I mean, you think it should be higher, and it should, but at least you guys are health conscious that you've got that number. So when I did this study across all breeds, once again, I broke it down into top third, middle third, and bottom third in terms of population. You expect lower numbers for the most populous breeds, higher numbers for the least populous breeds. And since you're riding the edge of the middle third to the bottom third, the middle third of the population of dogs, 11%, have chick certification that are bred. 11% of the dogs that are bred have chick numbers. The bottom 1/3, 16%, have chick numbers. Your breed, 72%. And here you can see, and you know the breeds that are more health conscious. Bearded Collie, 42%. Belgian Sheepdog, English Setter, Boykin Spaniel, Borzoi, Norwich Terrier, Caissons, Swissies, Border Terrier, Afghan Hound. You know the breeds that are health conscious and doing your testing, but you're beating most of them, and that's a very good thing. Bred with Heart is the AKC health panel, and that's part of their Bred with Heart program, and that's determined again by the Parent Breed Club, and most Parent Breed Clubs give the same things that are their chick requirements: hip, eyes, and thyroid. So I want to look real quick at one dog on the OFA website so you understand the strength of this website in looking at dogs and looking specifically for dogs. You can do an advanced search for Bearded Collies and say, I want to see a dog whose hips are normal, who's chick certified or has all 3 of those. I want a dog that, different aspects, and you can search and find dogs. So I did a search on a dog, and if it's your dog, congratulations. Ellen, a long time coming. Anyone ever heard of this dog, this bitch? Sure. Okay, yes? Yes. All right, good. So the first thing I want to show you is that this is a picture of her. Does she have a call name? Okay, whatever. So there's a picture of her dog, this dog on her webpage. This is Facebook for dogs. Or maybe this is Tinder for dogs, okay? But there's a picture, so if you donate $10 to the donor-advised fund of the Canine Health Foundation, which is money that can only be spent for research if your club determines that you want to spend it on research. So it's club-determined money. You get your dog's picture on their webpage. $10 donation, send the JPEG in, and it's on the webpage. So here's this bitch's results. She has excellent hips. Cardiac exam by a practitioner was normal. Dentition, full dentition. Normal elbow, normal patella, normal thyroid profile. Eyes normal. Collie anomaly normal. They qualify for chick because they've got the hips and the thyroid and the eyes done, and had another normal thyroid at 52 months of age or in 2019. And they've done 2 thyroids on this dog. Here is the dog's sire and dam, both chick certified, all of their test results. Here are the full siblings. There's 1 full sibling and their test results, hips and elbows. Here's the half siblings through the dam. If there are half siblings through the sire, those would be there with their results. Here are the 4 grandparents and their results. So this is the depth and breadth of pedigree results on this dog. If you want to look further at the vertical pedigree, that's a tool that you can search for any of the diseases: hips, elbows, health, having a chick number, eyes, thyroid, DNA, Collie anomaly, cardiac, dentition, patella. So we see that she has excellent hips, 1 good sibling, no offspring. Sire had good hips, 2 siblings that were good, 2 offspring, 1 excellent, 1 good. You've got a dam that's good, 0 siblings, 6 offspring, 4 good, 1 excellent, 1 fair. So this is the depth and breadth of pedigree information on the hips and these other complexly inherited diseases. And that's how you control complexly inherited diseases. It's not just the phenotype of that dog, but of their siblings, of what they produce, of their parents and their parents' siblings. There's only one affected dog here that an offspring of the great-granddam had mild unilateral hip dysplasia. So you don't see a lot of affecteds on the database because people are not releasing that information when they fill out their forms or for the OFA. So it's important when you fill out your OFA applications that you initial the box to release abnormal information. And I know that it goes against what we want to do because we love our dogs and we think our dogs are perfect. We want everyone else to think our dogs are perfect. But the bottom line is for complexly inherited disease, if we don't know where the disease lies, we can't select against it. And so for people that breed a dog whose hips didn't pass and don't release it, what you'll see is all their other information is up there, but their hips are not, and they've been bred. So what do you have to assume? You're going to assume that the dog's affected anyway. I mean, why would it be bred and not have its hips up there? Or they're not a health-conscious breeder, which means you can't trust what they're breeding anyway. And so it's really, we need to move away from the stigma of genetic disease. No one wants to create genetic disease, but it happens. And we can leverage ourselves against genetic disease, but we need to use the data and we need to have the proper data. So you need to release abnormal results. I'm not going to do this one because we're short on time. I release abnormal results. But here is, based on the hip testing, what percentage of Bearded Collie owners have released, have checked off to release abnormal results. It starts up here at 10% in 2001, and you can see it gets up to 22% in 2007, goes back down, comes back up again. From 2015, except for 2015 through last year, you're above, you're up around 23%. And so that's a good percentage to be. Actually, the average for all breeds is 23%. But that's across all years. So you're getting pulled down by your earlier years. We want to see that percentage much higher. We need people to understand it's not, yes, it reflects their dog, but it reflects the phenotype of their dog. And if I have a fair, I want to breed to an excellent so I get goods next time, because that's how things are working in that way. If that fair dog has other qualities that I want to reproduce, or even a mildly affected dog. Although for your breed, I would say to breed a mildly affected dog, it's got to be pretty outstanding in all other aspects because your breed has such a low percentage. If you've got 15% dysplasia in your breed, then you might be using some milds because you've got a much higher frequency. But you're so low right now, using an affected dog has to really be outweighed by a lot of other things. As long as we keep problems secret, we will not be able to deal with them. So hiding the results, it doesn't help anybody. Doesn't help yourself because it's going to come back to bite you later. Why didn't you release those results? I produced an Addison. Well, you don't have an Addison registry, and hopefully we'll have tests for Addison. But if there was an Addison registry and you didn't have your dog up there, but you knew it was Addisonian and you bred it, it's going to come back to hurt you. Breeders need to be informed about the problems occurring in the offspring that they produce. I don't care how many litters you've ever bred in your life. If you breed a lot of litters, good for you. I hope you're doing the right thing. And yes, you've got work to do every year. Because the birthday of every litter, I want you contacting your owners, the last contact you had, whether it's a phone call or an email, and say, happy birthday, how is your dog doing? And even if something wrong is going on with that dog, you're the one that reached out, because I get choked up on this. You're the one that reached out. You care about what you bred and what you produce, and it's important for you to know what's going on with what you've produced throughout their entire lifetime. So if something's gone wrong, you can commiserate with them and say, I need to know those things. I'm so sorry. I'm trying to do the best that we can. They're not going to blame you for that, okay? Because you're reaching out to find out what you produced. But it's important, if you don't know what you produced, and this is another thing that I say, because I speak to commercial breeders all the time. And the only thing commercial breeders can do is pre-breeding screening, because they have no way of following up on their dogs. And so I will say to you, the only difference between you and commercial breeders is your ability to follow up on your offspring. Because genetically, it's true. That's the only difference, is your ability to follow up on your offspring. You all need to be doing genetic screening and selection, but you can follow up. So it's important you do that. The days of stigmatizing conscientious health testing breeders who have produced dogs affected or carrying hereditary disease are over. I know that's a pie in the sky thing for me to be saying, but you know, it's where we are today. It's where we are today. If you're hiding it, it's gonna bite you, and then why were you hiding it? If you have a direct gene test, you only need to test the genotype, Collie anomaly. You only need to know the results of the breeding stock to make breeding decisions. If you only have phenotypic tests, hip, thyroid, temperament, elbows, or no test for carriers, you need to know the carrier and affected status of relatives. Without tests for carriers, you want to breed higher risk individuals to lower risk based on knowledge of affected dogs in the pedigree, depth and breadth. Replace the higher risk individual with lower risk offspring. Repeat the process in the next generation, and it requires open health databases. So sex-linked genes, okay. Same breed and replace as autosomal recessives, but if you've got females that are high risk of being carriers, you don't want to breed them if it's a sex-linked disease that doesn't have a genetic test, because carrier females, half their sons will be affected. And you want to avoid affecteds. With an X-linked gene, if you pick a normal male to carry that line on, you always lose the gene, because males are either affected or normal. You can't have carrier males. And males are going to be much more frequent with X-linked genes, because for an affected female, they must have an affected father in order for females to be affected. Lastly, polygenic or complexly inherited disorders, which is most of what you're dealing with. Identify phenotypic traits tied to underlying genes. So there's three things we're talking about. Identify phenotypic traits that are tied to underlying genes to try to break down that phenotype. Breadth of pedigree provides more information on the possible range of genes carried. And treat disorders as threshold traits where several genes must add up to cross a threshold and produce affected dogs. So you want to breed normal dogs from mostly normal litters. So if you're looking at hip dysplasia, there's no hip excellent gene and a hip good gene. You want to have round femoral heads. You want to have deep sockets. You want to have round femoral heads that are deep in those deep sockets. Okay? You don't want to have laxity. You don't want to have osteoarthritic changes going on. There are genes just for osteoarthritis that contribute to liability to hip dysplasia and all other musculoskeletal diseases. So there are many different things that you can select against. If you've got a dog that's fair because it's got a little laxity, then maybe you need to do pen hips and pick a stud to breed to that has tight hips and has a tight pen hip that is purely related to laxity, so that you're selecting for tightness of those hips. Depth of pedigree, most people will do 3 generations of hips and advertise that, but breadth of pedigree gives you more information on the possible liability genes that dog has. If the majority of litter mates have normal hips, then you have to consider that this dog has a preponderance of hip normal genes. But if the litter mates, there's a lot of hip dysplasia or Addison's, or there's 1 or 2 Addison's or an SLO in a litter, then you have to consider, even though your dog doesn't have the disease, they have a high liability of carrying genes for that disease. And so you need to question what is going to be produced in that type of mating. And lastly, polygenic disorders are threshold traits. A number of genes must cross a threshold to produce an affected dog. So if we say theoretically it takes 5 genes to produce an affected, if the 2 parents on average are right at that threshold, we can't be surprised to see affecteds. Here you've got an affected dog, and so you've got high numbers of affecteds. But with threshold and complexly inherited genes, we must understand if 2 phenotypically normal dogs are bred and produces a dog with Addison's, SLO, hip dysplasia, whatever, both parents had to contribute liability genes for that disease. It wasn't just that damn stud dog that you bred to. Okay, both parents, 2 phenotypically dogs producing an affected, both parents had to contribute. Now, you can look at the families and see where there's greater risk coming down. One parent can have greater risk than the other, but you're still passing on liability from both sides. This is, real quickly, from an article that we published in the Veterinary Journal in 2011. It's based on hip ratings on close to 500,000 dogs, all breeds, where both parents also had their hips done. And so we rated the dams from excellent to severe 1 through 7, and we rated the sires excellent to severe 1 through 7, and did the combined parent score. So you have to recognize that over 200,000 of this 500,000 are good to goods, which is a 4. But an excellent to a fair is also a 4, and an excellent to a fair on the dam side is also a 4. And you see that 9.4, 9.6, 9.6, all of the colored diagonals here have the same combined parent score. And when we did the statistical analysis, they are all statistically related to each other. So it's showing you that the grade of hip is definitely related to the liability of passing on genes for hip dysplasia. I want you to look at one other thing here. Here's moderately affected to severely affected. There's 49 here. And there's severely affected to moderately affected here. There's only 52 dogs here. There's only 100 dogs that we're looking at that category there, which gives us a 13. And I only wanted to point that out because that's the only outlier on this score of combined parent score in terms of liability for hip dysplasia based on those 100 dogs of moderate to severely affected. Otherwise, hip dysplasia is completely passed on as an additive genetic disease based on OFA hip rank. There's a difference between a fair and a good and an excellent. And you should be taking hip radiographs on an anesthetized or deeply sedated dog. I know that if you have a dog, it used to think as a veterinarian that if the dog's really calm and you can get a good position without anesthesia, that's fine, and that the reason for anesthesia is more for positioning. But we now know that without muscle relaxation through sedation or anesthesia, it does not catch all of the hip dysplasia. And as of January, OFA is now going to identify on the website physically versus chemically restrained dogs. So you know the difference between those two because they are different populations in terms of reflecting hip dysplasia. And if you have a normal, you take that same data, and if you look at how many normal grandparents there are, with each normal grandparent, the amount of dysplasia goes down based on any of those combined parent scores. And again, it gets messy here with severe to moderately affected dogs because there's few numbers, and who the heck's doing those meetings anyway? So once again, depth and breadth of pedigree. So, end of the seminar. Breeders should use health screening to identify carriers or risk of carrying disease liability genes, work to breed away from defective genes, prevent the reintroduction of genes in future breedings. Each one of you is dealing with different issues. A couple of you might have hip dysplasia. Some of you might have Addison's. Some of you might have SLO. You're all dealing with different combinations of things in your dogs that you need to be paying more attention to and trying to select against and doing the best that you can. Each breeder must assess their own breeding stock and determine their own rate of progress, replace carriers with normal testing offspring, or decrease the frequency or carrier risk with each generation through pedigree analysis and the OFA website. A healthy breeding program does not continually multiply carriers, does not limit the genetic diversity of the population, and is geared towards producing quality, genetically normal dogs. Your breed, you have done an excellent job as custodians of your breed. You have maintained genetic diversity. You have avoided popular sire syndrome, and your generational 10-generation inbreeding coefficients are going down due to selection and breadth of your pedigree, not due to your looking at the number and making it go down artificially, but actually in breeding for quality. And the genetic diseases you're dealing with, hips are great, elbows are great. You've got Addison's and SLO and thyroid as autoimmune diseases. But even though they're all grouped together as autoimmune diseases and maybe have some basis of causative factors that are in there, they're still individual diseases that you need to select against individually. And hopefully the researchers can give us more tools to use to help us breed away from those. But you have the tools of your knowledge, and if you want to talk about and maintain registries of affected dogs, if that's something that your breed is willing to do, that would be very helpful for you as breeders as well. Lastly, how can we educate the public? We need to make them more informed consumers of dogs and puppies. So if someone contacts you, and even if you don't have a litter planned and you need to send them to someone else, take a couple of minutes and talk to them about what they're looking for in a health-conscious breeder. Tell them that you want to see The original test, copies of the original test forms that show, or on the OFA website, the hip status, the eye status, the thyroid status, on a minimum on the dogs. And that if the breeder can't produce those for you and they just say, oh, they're all healthy, they're all normal, I have only healthy dogs, then that's a breeder to avoid. Because if you have that documentation, you are more than happy to share that and show that you're a health conscious breeder. It's not, oh, the paperwork's somewhere, I can't find it right now. You know, if you're breeding, this is something that's important and that you will do. Able to discern responsible health conscious breeders and knowledgeable about genetic testing. It's the public that drives the engine that sells dogs. If they can go on the internet and buy a dog, you know, more dogs are going to be bred. Okay, so we need them to be discerning and spend the same amount of time that they spend to buy a car or a computer as they researching it as they do when they buy a dog. Okay, that is it. We went over a lot. I guess the fact that I haven't lectured to a group in over 2 years now has made it a little slower, but I hope what I've included was helpful to you very much. So if there are questions you want to ask anonymously, I'll take a few minutes of questions. If you just want to raise your hand and ask a question about anything I've covered today, I'm more than happy to do so. I know it's late. I know it's early in your national, and you need to get some sleep and be out there tomorrow morning. But I do appreciate your attention, and hopefully there's a lot of information here, so you'll need to review the video when your club has it available to you, and hopefully you take some of this to heart and can breed healthier dogs. Heritability factor, or H2, is what the scientists refer to. We still compute that. So the heritability of Addison's disease is 76%. And what that means is 76% of the variation of Addison's disease is purely genes, and that 24% of the variability of Addison's disease is environmental. Whether it's stress, whether it's what other factors that are not genetic that affect the expression of Addison's disease. So heritability or inheritedness is still a factor and something we can compute much easily. You know, before it was purely based on pedigree calculations, and now it's based on molecular genetics as well. So it is definitely a factor, and definitely something that allows us to give you more information in that regard. And so again, they just published 76% heritability of Addison's, and that was published just last year. So there are refinements to that. But you have to recognize that inherited diseases, complexly inherited diseases, don't have to be that heritable. That's why Addison's has a major recessive gene involved with it, because it gives it that high heritability. So that there's a major gene there, which if they find would explain, you know, most of the Addisonians. And then there are other genes that are going to alter that a little bit. Whereas hip dysplasia, it's purely additive. So the heritability of hip dysplasia or inheritedness is only about 23%. And that's been repeated again and again and again after many, many studies. But so you might think, well, it's not very heritable, so why the heck are we taking hip x-rays? But the bottom line is 23% is still highly heritable. So if we understand that milk production, egg production, beef production, the heritability of those measurements are all in the low 20%. And look at all of the gains we've made in egg production and milk production and all these other things. So you have to pay more attention and work harder if you have a low heritability. But for many complexly inherited traits that you're selecting for or disorders that you're selecting against, you're still going to get progress, just not as fast because the heritability is lower. There are breeds like the otter hounds, there are breeds at the bottom of that population scale, of that lower third, that have very few litters per year. And some of those are so afraid, because otter hounds have a lot of hip dysplasia and a lot of epilepsy, as an example. So I don't want to single them out, but they're ones that are actually addressing the problem. So I'm using them as an example. And so I've spoken to them, and the breeders are afraid to breed. They're afraid to produce another epileptic. They're afraid to produce another dog with hip dysplasia. And I told them, you don't breed, just kiss your breed goodbye. You have to breed. But so you need to do your best and make this next litter better than the one before. and work your way and grow your population and work your way away from it. If you're afraid to breed because you're afraid of producing affected dogs, then you're not contributing to the growth of your gene pool, and what are you doing? Why do you call yourself a breeder? So you need to breed, but you need to make the best possible choices you can. And as long as you're breeding with your eyes wide open, yes, maybe there's risk for many things in the background there, but you're trying to minimize that risk. If you've got higher risk for one thing, you need to really ask the questions of the owner of the a bitch or dog that you're looking to mate to say, I've got Addison's risk. What do you got? I need to breed to a line or a family that has had less than what I have, so I can diminish that risk. And you need to do that with each of the things that you're worried about. But you need to breed. And if you've got a litter that had only one offspring that was born, and another thing, I don't want to make it stay here a lot longer because I got a lot of stuff I can share with you. Before ultrasound became a common thing, we didn't realize how much embryo loss occurs. But now that we do, and you guys have ultrasounds done at 25, 28 days, and there's like 8 puppies there, and then 3 are born at term, there were 8 feti, and you've got fetal loss. So that could be environmental, it could be genetic, but if you've got a bitch that consistently has low number litter size, or a line with low litter size, then maybe you're carrying some lethal, fetally lethal genes, and you need to outbreed and do matings with a lower COI, which is going to be an outbreeding, and maybe bring in some new genes that are going to counteract some bad genes that you might have. And if you do that and your litter size goes up, then I think that tells you you've got some lethals in there that you need to try to work away from. We don't have tests for them, and if breeding to certain lines gives you the low numbers and certain lines gives you higher numbers, then you want to avoid this line and go to that line with your line. And maybe that line doesn't have problems with others. So it's not their problem as much as the combination. It's not easy. I mean, if breeding was easy, we'd all be sitting in that front row at Westminster, but you just do your best. I mean, we love dogs. We love breeding, and we love our breeds. And so we do the best that we can. And that's all you can ask for. I can never guarantee I'm not producing disease in my dogs. And I hope that, bad things aren't happening. But when they happen, at least I know them, and I can deal with that. And I can try to prevent that in the future. But we need to breed as breeders, and we need to make the best decisions that we can. Thank you, everyone. Have a great specialty.